This needs to be the last day. Last day, whatever. I think this is stream 6, whatever. Making a stupid GPU shader. I don't know, I've like gotten this far. I have all the pieces. I have the stupid Vulkan API. It does all the steps to like initialize whatever the fuck, the stupid structures that pass stuff to the GPU, because the GPU, it doesn't do shit. It's all CPU bound, and the GPU is just free to do like video card stuff. And the CPU is basically doing the bulk of the work. If the GPU actually did work, then it would have to be higher powered. I think like the current GPU is like 2 point. It's like weaker than this freaking 16-year-old i7. This is like a first gen i7. And the most modern consumer grade GPU is it has less gigahertz whatever performance than this 16-year-old PC. So like this 16-year-old PC, first gen i7 has like 2.8 gigahertz. What's modern GPU? I don't know, GPU seems like a big fucking scam. You like interact with the GPU through data structures. The whole fucking instruct, not the instruct. The whole fucking instruction architecture, whatever, is completely fucking hidden. Okay, maybe not. AMD has it's faster than NVIDIA? Are you kidding me? How is NVIDIA's only 2.4 and then AMD is able to freaking 3.13? Alright, never mind. I guess the video card is faster. NVIDIA is dropping the ball. I guess NVIDIA expects people to pay, pay. All that above, all the above. It expects people to like continue to do what they're doing for like subpar shit. Aren't they like adding AI to NVIDIA cards? And they're only like the video card does what it does, right? And then they're gonna add AI to the video card. It's like an NVIDIA card, even if it has all the chips on the bus or whatever, it's mostly going to be in the freaking system on chip. They're going to add AI to like a 2.40 gigahertz CPU. They're going to add AI. That means they're going to have to sacrifice something else. Frame rate, resolution, something's going to lose. If AMD adds AI, they have like they could waste a whole gigahertz of processing extra because there's more there, so they can like add to the card. But Nvidia's like, you're paying fucking top price for a freaking 2.4 gigahertz, and this is on the bus. It's on the fucking PCIe bus. Why do things on the PCIe bus have that kind of speed? The whole CPU architecture is stupid. It needs to be like redesigned. You might as well have like 2 fucking CPUs on the same fucking board and have like the fucking GPU plug into a socket or some shit. It's just fucking dumb. And they all like fucking access main memory, which is the RAM, to interact. Alright, so first Gen i7 is 2009. So 15 years, 10 months. So this first Gen i7 PC is faster than the most modern NVIDIA GPU, CPU. And then AMD is basically kicking their ass by releasing a 3.13. Is NVIDIA gonna keep up with the competition? Do they have to? I mean, like Apple got tired of paying for Intel CPUs because they're so damn expensive. And they got tired of x86, so they made ARM to like control it all. I'm pretty sure people are tired of paying for NVIDIA in their shit. Especially for NVIDIA to release that. That's so fucking slow. That's like so damn. Even if it's a fucking ARM processor, that's fucking slow as fuck. That's why probably the CPU has to do the bulk of the work. It has to fucking set up where the fuck it sends over the fucking pipeline. I gotta figure all this shit out now. I got pretty far off pure assumption. I gotta like actually figure it out and get stuff running. Why clock speed isn't everything. Yeah, of course it's not everything. But there's a big difference between 2.41 and 3.1 gigahertz. So I gotta get this stupid GPU done today. Shader thingy. This sucks. So like I think this is like stream 6. So if I go on the calendar here. Oh my god, it keeps getting freaking. So I guess last week, 1, 2, 3, 4, 5, 6. A couple weeks ago, it's been a bit. Yeah, time keeps moving. Every day is another fucking day. And it's be the next day, and the next day, and the next day. So like 6 days I've had it. This is annoying as fuck. Put me up a week. I need to be done today. I still need like 3 or 4 days to finish converting it. The whole thing to 64-bit. My actual engine, not really shader related. I literally need a shader for the stupidest shit. I only need a shader. You just pixelate the screen. When I'm working on code that I can't just give away for free. That's all I need. And I can't find one that's like usable that doesn't eat up a ton of CPU resources. So like, this is a shader program, whatever. It just needs to pixelate the screen so you can't see exactly what I'm doing. You can see what I'm doing, but you can't copy paste that or convert it back to the original source code. It's way too pixelated, and there's way too many possible character combinations. I'm using more than just the 256 characters of the ACI jar set, even though you don't use all 256, it's really only 0 to 127 characters. Because above that are the special characters, but there's also like the characters that are like non-printable characters, but the range of like actual usable characters. Anyways, it doesn't matter because there's no way you could like turn this, and I would challenge anyone because it really wouldn't be worth your time. You should just write your own fucking shit if you want to try to steal something. And I'm gonna like really obfuscate the runtime. So trying to like steal the actual code when it's done, that'll be just as much fun as trying to like convert like screenshots that are pixelated to actual code. So I need to make sure like I'm not giving away anything for free, because I would defeat the whole point of like doing this if I release it and it's already like out there because it's taken or whatever. So I just need a shader that does this. I just need to like simply pixelate the screen like this, so that as I'm working, you won't be able to see exactly what I'm doing. This is all I need. And I'm like a week off, or 2 weeks off, 3 weeks off now. I'm way off. I just gotta get this done. I'm trying to set up Linux. That took like a week. I had to install it on this old ass CPU because I'm setting things up for low end computers and high end computers. So I'm trying to support from the bottom and then up. So to make sure like I can run it on this super old 16-year-old PC, first Gen 7. Because whoever runs on this computer will run on a newer potato. This is like a one potato. I think there's like 14. It's 14th gen Intel CPUs, whatever. That's like 14 potatoes. Anything that runs on one potato is going to run better on 14 potatoes. But I still have to like add support for the newer instruction set add-ons and stuff, like SIMD and AVX. This one doesn't have AVX, it's too old. So I can like add support for that too. And it's like lagging because it's starting up. It's a lot of shit to load. So I'm way off, but at some point, hopefully very soon, I have to get the share done today. It's taking way too long. I'm hoping for 2 months, maybe August and September, and I'll be done. Technically not done. I still need to like clean up everything afterwards when it's done and package it. Probably 3 months. Except when I get to the standard, when I get everything running, I get to standard. I'm gonna go from page 1 to page 816 of the JavaScript standard. Every single category section, like conditional operator. I'm gonna stream going through every single one of these, and I'm gonna put in the timestamp, whatever, in the description. I'm gonna meet the entire standard from top to bottom, and be the very first engine to ever meet the standard of any of these standards 100%. Very first. Because it's apparently too difficult for like companies worth trillions of dollars to meet any standard ever. There's like the 2009 version of standard, 2008, 2007. Even like 12, 13, 14 years later, the standards haven't ever been met because it's too difficult. And the old standards are only like 200 pages. They're like way smaller. This is like the 2009 JavaScript standard, and it's only 252 pages. So, like 800 pages, it's like, well, you kind of have a point. That's a big standard. I mean, with trillions of dollars, that's still a lot of pages to meet for a standard. But for trillions of dollars, not being able to meet 252 pages, that's kind of like, are you fucking kidding me? You're worth trillions of dollars, your company, and you can't even meet 252 pages, but then you can like call yourself a JavaScript engine. It's like, what the fuck? And then it's not even JavaScript. JavaScript is a brand. This is the ECMA 262, the standard for JavaScript. So I don't know, whatever. But I'm also gonna like make my own standard or adjust the standard after I meet the standard, because I'm gonna be adding support for making video games and stuff in simulation, emulation, and like high performance stuff that you don't do in JavaScript right now. But that's whatever. So hopefully 2 months, I can go from top to bottom, 800 pages. I get the shape done today. I got the Vulkan window, I got the setup. I think I need to like make a triangle in the shaders or whatever. Just like the command line, the command buffer, I don't even fucking know, it doesn't matter, I don't give a shit. Just gotta like figure it out. And just get the fucking screen to the video card. Apply the shader, and I'm back to programming on the JavaScript engine. So, I don't know. Every day's another fucking day. It's taking way too long. And I can't stand the 8. Winter needs to come back. I can't stand it. It's too fucking hot. Even with AC, it's fucking hot. I gotta like look up GPU stuff now, how to like actually make the pipeline and shit. Because I have everything set up, but I don't know what it's doing. And it's making like a black screen. It doesn't actually do anything useful, so I don't know if it's working totally. But I do get a window when I run it. So I do know it made the window, and I know like all the calls were successful. I just don't get any picture on the screen yet in the window. But I did make like whatever a feed to access to capture the desktop too. So I'll just do that later. First I gotta like look up, figure some stuff out. I gotta turn the fan because it's so freaking hot. So I don't know, I'm gonna like look stuff up, try to get started, and then whatever. Hopefully be able to like explain what's going on, because I don't know so far. I've just been like typing shit in, looking at what needs to go where, plugging it in, setting it up. Now I have everything I need. I just need to like connect it. So that's what I'm gonna do. I'm gonna turn my fan, find some music, and try to figure this shit out. And I don't know, yeah. I should have never went on Windows. I should have like installed Linux in the first place. Because now I'm like converting things from Windows to run on Linux and nothing worked. To like rewrite things, redo things, it's taking way too long. So I'm gonna get started, whatever. Assumption only took me so far. I gotta like figure out what the video card actually does, what to send to where, and what to set to what, to like get further, whatever. The video card sucks. Python is terrible. It is so slow. It eats up so much resources. I don't want to rewrite everything to assembly language. This shit is so bad. It's so pathetic, the performance. It's like an old ass computer. And to waste clock cycles on a shitty language, even on a newer computer, is fucking stupid as fuck. Like, just because it's a new computer. And to waste fucking so much CPU power on processing shit. Shit ass language. It's dumb as fuck. It's like having like the highest end consumer grade gaming computer and then like processing trash or like a garbage disposal or like I don't know, just like doing something stupid just because you can. And it's like I have the highest end computer and I'm running the shittiest language that sucks ass because it's standard. Everyone uses the same shit and it's garbage. And next year the computers get faster, so the computer languages can get even dumber, and the programmers can get even lazier, and things can get even less performant. But it doesn't matter because as long as you can run it, you can like brag about how you can run shit, just complete trash, waste electricity, CPU cycles, instead of actually running stuff that's like performant and you actually get what you paid for. Because like at some point running all this garbage, it's gonna take a toll on like what you're actually doing. I don't know, it's fucking stupid. Python is just dumb as fuck. It's the dumbest shit ever. I gotta focus on fucking GPU, it's just as dumb. Oh, everything's fucking stupid. Why is this not working? Oh, now it's working. And I hate the fucking indenting in Python. It pisses me the fuck off. Let me indent shit the way I want to fucking indent it. For fuck's sake, I don't fucking give a fuck about the fucking indentation. For fuck's sake, it's so stupid. And then when I like change the code, you gotta fucking adjust the fucking indenting on all the shit below it. Just let me make a goddamn block to contain the fucking code. It's really fucking simple. No, Python pisses me off. It makes me angry. I fucking hate it. It's the dumbest fucking shit. And it is so slow. It is faster to access something in a lookup table, like a hash map, like actual map, than it is to do addition, subtraction, addition, subtraction, freaking any arithmetic or bitwise operation. It's faster to access memory than it is to add two numbers. What the fuck is that? In the speed difference, like sure, adding two numbers that accesses two places in memory. When you do like a single access, it's one. Except you could do like 10 accesses. It's still gonna be faster than doing like a single fucking operation. What the fuck? Python makes no sense. It makes me angry. It's so fucking stupid. Alright, I gotta figure out the video card shit, so I'm gonna do that. Turn on a fan and find some music. It's so fucking hot. I need winter to come back. I need winter. I can't take it.
Function declaration 1. Return a new empty list. Try statement. Try block catch 1. Let declarations 1 be var scope declarations of block 2. Let declarations 2 be var scope declarations of catch 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally 1. Let declarations 1 be var scope declarations of block 2. Let declarations 2 be var scope declarations of finally 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally 1. Let declarations 1 be var scope declarations of block 2. Let declarations 2 be var scope declarations of catch 3. Let declarations 3 be var scope declarations of finally 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch parameter, block. Return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list, module item list module item 1. Let declarations 1 be var scope declarations of module item list 2. Let declarations 2 be var scope declarations of module item 3. Return the list concatenation of declarations 1 and declarations 2. Module item, import declaration 1. Return a new empty list. Module item, export declaration 1. If export declaration is export variable statement, return var scope declarations of variable statement 2. Return a new empty list. ECMA International 2024 107, 2.8 Static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list item 1. Let names 1 be top level lexically declared names of statement list 2. Let names 2 be top level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item, statement 1. Return a new empty list. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 Static semantics. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax directed operation. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L.
It's, I don't know. I gotta leave the fan on. It's too fucking hot.
P, E, D, capital.
You turn up the AC, but it's still fucking hot. Like, just, the air is hot.
And returns
It's not just the temperature. It's like fucking, I need winter to come back. This is terrible.
statement list item.
I gotta install noise storage on this computer, or I have to virtualize Linux on Windows. Either of them are going to take up time.
L,
In time, it keeps moving forwards.
C, A,
Time keeps moving forwards.
Y, capital S,
Here's like, damn it, wrong thing.
E, D, capital D,
here's a calendar. So every day, it's another day.
A of statement list.
So today is the 24th, tomorrow is the 25th, then it's the 26th. Every day is another fucking day.
E.
I'm tired of wasting my days on setup. None of this even has to do
I.
with the goddamn fucking JavaScript engine. For fuck's sake.
Capital
I'm tired of fucking having to do stuff that the modern operating system should do at a fundamental level. For fuck's sake.
R. F.
But it doesn't, because the modern OS is absolute shit.
Of declarations 1.
And this video card stuff is a fucking joke. What the fuck?
Return and
Oh, everything's so dumb.
list item.
So instead of like the operating system actually having operations to run on the system,
And statics amount.
you fucking write Python, the world's worst, shittiest, crappy, and then you have like these shell files. This is terrible. This is pathetic.
Actions. Statement list.
Oh, I hate this so much.
Statement list item 1. Let names 1.
So fucking stupid.
Let names 2 be top level
So, this is how you make a triangle,
variation of names.
I guess, apparently.
List item. Declaration.
It says right here, drawing a triangle.
Turn the bound name.
Because of course triangles are like the optimal shape, or
2024.
it's what's said in practice, the reason why they use triangles and not squares.
Declarations right.
Because you can make anything with a triangle, any kind of shape on the GPU.
Statement. Labeled
This is some stupid fucking shit.
names of statement. Return var.
But it's what's said, so whatever. Sure, of course, you can make any shape with a triangle.
Function declaration.
You can even make a square with two triangles.
Labeled statement. Label identifier.
You shouldn't have to like represent shape with triangles.
Item. Labeled item.
I won't get into it.
Statement is statement.
Everything's fucking dumb.
Return
This isn't learning. This is like conformance.
names of statement. Labeled
I fucking hate it.
declaration. Return bound names of function.
The GPU needs to expose the fucking architecture to work with it directly. But instead, it's hidden behind a whole bunch of shit.
Arguments and returns a list of
Because behind all the stuff that's hidden is like a shit ass architecture.
list. Statement list item 1.
Oh, everything's fucking stupid. I gotta like accept. I'm gonna have to like figure this out. So I'm gonna make a triangle.
Let declarations to be top level vast.
So to make a triangle, here we go. Here's like the fucking tutorial. This is so exciting.
Of declarations 1 and declarations 2. Statement list item. Statement.
Yeah, no more ads.
Return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item.
It says you create a Vulkan project, so I would assume that I have works, even though I didn't follow this.
Then, a let declaration be declaration part of hoistable declaration.
Alright, so,
Return a new empty.
oh, I hate C++.
Label identifier. Labeled item. Return T. He top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics. Contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument labels.
Okay, so,
String.
what the fuck does malloc have to do with the video card? This is ridiculous.
Variables.
Everything should be done on the fucking video card. The video card runs at like 2.40 gigahertz. The fuck? Why the fuck isn't this being done on the video card directly?
Statement lists.
This is stupid as fuck. You should be able to send code to the GPU and run it completely autonomously from the goddamn CPU. This is dumb as fuck.
Return contains duplicate.
Oh, I hate this shit.
Argument label set. If statement. If expression statement else.
I should look this up on the Mac.
Duplicate. B contains duplicate
I had to just read stuff.
with argument label set. 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement.
And I don't want a virus on Linux. It took so long to set this up. I'd be so pissed if I got a virus. Freaking random ass links have like links to dirty websites. Last thing I need. I have to figure out how to clone the drive when I'm all done. So I can like save the OS in a working condition. To like pull it up in case it crashes. Man, I hit full screen. Why is all this shit on the damn window? This isn't full screen. What the heck? Oh my god, this is stupid as hell. I hit full screen. I want full screen, not make it full screen but keep all the shit at the top of the fucking window. I don't think Opera knows what full screen is, the browser, Opera. Opera has a web browser designed for gaming, and it doesn't even have games on it because JavaScript is so shitty. So when I release my engine after it meets the standard, maybe there could actually be games on Opera. The fucking, what is it, Opera GTX or something? GX. So they have like the browser for games. But you can't make games in the web browser. You can't make 60 frames per second legitimate AAA performance grade A games in the browser. You can make shitty games in the browser. You can make shitty websites in the browser. Because that's what you can do with web development. Because web development is very difficult. Because the tools you have to work with, they're like broken. A bunch of broken tools. So like Opera GX is like a browser for gaming, but there's no games in the browser. Luckily I'm making a JavaScript engine for gaming, so then there'll actually be games in the browser. And I'm having to like learn about this fucking GPU shit. I just don't give a fuck. I just want to make the fucking product and be done. And there's so many hoops and shit to jump through. I just gotta jump through the minimum amount of hoops for now to get it running and then get done. So at least I'm learning something, what I'm getting into. And I can apply it after I make the shader. So it's not a waste of time, it's just annoying as hell. Just when I actually get to like making the game engine part, if I have to make a game engine, I might sell it to Google or whatever, or Internet Explorer or whatever. Or I might just compete. I think I have to compete. Because the companies are so fucking shady that it might not even be like worth the time to like try to sell the engine. But I'm like, I don't know, it depends. If it's not gonna be too much work to like compete, I'll just compete and make an engine. Or I'll sell it. I don't know. Whatever. It's like, I'm going to meet the JavaScript standard, modify it, but I'm not stuck to the web browser. I can do whatever I want. There's like a ton of like options, choices, routes I can go in. What is this, a window? Any window? It's a waste of space. Here I go. Super exciting. Video great stuff. And then when I'm done with this, then I can ask chatbot how to do whatever and like give it exact instructions, and it should give me like a better answer. Because right now, chatbot's just all over the place and it's not giving me any kind of solution. If I can draw a triangle and I can get it running, then I can ask chatbot, this is how I make a triangle. What do I use to get stuff from the video feed into the video card? And there should be a way to get the video from the video card to the main RAM and send a command in the command buffer or something to have the video card grab the video from the RAM. I shouldn't have to use the CPU to do the work of making memory copies. What the fuck is that? That's just ridiculous. That's wasting CPU resources when the GPU is supposed to be GPUing. Like, the GPU is supposed to GPU. So let the GPU GPU. Why does the CPU have to step in and fucking copy memory?
Base code. Vulkan tutorial. Opera. Just like each chunk of memory allocated with malloc requires a call to free, every Vulkan object that we create needs to be explicitly destroyed.
Like, this is way too much on the CPU side to just interact with the fucking GPU. It's fucking dumb. The GPU should be completely autonomous. I'm gonna check out, what does autonomous mean? I'll ask it, yeah, I don't know, whatever. Alright, so let's jump on.
What does autonomous mean and how is the GPU not autonomous from the CPU in relation to having the CPU do copies to the RAM to send back, or the CPU having to set up the command buffers, or the CPU computing the work to send? How does the GPU not handle that all on its own, entirely separate from the CPU? It seems misleading to call it a graphics processing unit when it relies on the CPU to feed it the graphics to process. The GPU should do more on it end, right or not?
And chatbot says,
You're thinking in exactly the right direction. This is a deep and meaningful question that touches on the architecture and division of labor between CPUs and GPUs. Let's unpack it in layers. Magnifying glass. What does autonomous mean? Autonomous means independent, able to operate on its own, without needing constant instruction or supervision from another component, like a CPU in theory. A magnifying glass.
some people, they need to be autonomous also. They need to learn. I won't get into it.
In theory, a fully autonomous GPU would be one that decides what to render, figures out how to render it, moves its own data around, builds its own command buffers, and does so without needing the CPU at all.
Like, does that not make sense? Why the fuck do I have to use a Vulkan to interact with the goddamn CPU, GPU? Why do I have to use this extra layer of program? The GPU, it should be the GPU. It should have an interface. You shouldn't have to go through a middleman that's made up of like these random ass data structures and these conventions set up to like, I don't get it. It makes no sense. What do I know? I just know like x86 and stuff. And like, I don't know. The GPU stuff is all new. This seems, I hate this. I don't want to do this. But I'm gonna have to now. Because like, the CPU is real. And it's like, you can interact with it, and it's like there. You can like get the instruction set, you can do stuff. But with the GPU, and like, other things on the CPU, it's just fake as fuck, and it's just software driven. And you follow these, constructs or whatever, and it's just annoying as hell because it's like it's only relevant until it changes and everything's fucked and things change over time. You're not gonna be like guaranteed that something will work forever, just like the modern operating system. It's not gonna last forever.
Thinking face. So why is today's GPU not fully autonomous in modern systems? Even in 2025, the GPU still depends on the CPU for a lot of things. Brain. The CPU's roles in a typical graphics workload. Game logic simulation. The CPU computes where objects are. Physics. AI, etc. Command buffer creation. The CPU builds the list of instructions, draw calls, pipeline state, shaders that the GPU executes. Memory management. The CPU often allocates or maps resources, textures, buffers, and manages transfers between RAM and VRAM.
need to get back to working on the engine. It's been like 2 weeks, I think. Oh my god, it's taking so long. Just getting on Linux. I need to get to the standard. I can't take it. Oh my god, this is stupid.
The GPU's role takes those instructions and executes them massively in parallel, does math-heavy work, rasterization, shading, texture sampling, post-processing, etc. Works fast, but only on the tasks it's told to do. The GPU is not autonomous because it's designed to execute, not decide. The CPU is still needed to manage, schedule, and feed it work. But the GPU is slowly taking on more responsibility as the ecosystem evolves.
That's just dumb. I should be able to load into the GPU a fucking program called Program on the GPU. Just like you run an exe on the computer. There should be a GPU exe. And then you run it, and the GPU does what the exe says. I don't know, what do I know? All I know is I'm gonna have to go through and learn how to program for the GPU through Vulkan. Because that's how it is. So, I have to suck it up. I don't consider this learning. I consider this like conformance. And like, people think that learning different program languages, different ones, like if you learn HTML, you learn JavaScript, learn this, that's called learning. That's called like reframing. You know something, and then you reframe it to something else, and you reframe it to that. That's like really boring. That's not learning. Learning is when you put new ideas together, new concepts, you come up with like some other idea. It makes you think different. I've been going through like a week now of not learning. I've not learned anything. I've not written any really new code. I remember a couple weeks ago, I was like, oh, on the second, I plan to be like done with converting the engine from 32-bit to 64-bit. And then I'll be going to standard on the second. Now it's a fucking 24th, for fuck's sake. I needed a shader program. That's all I needed. I can't get one. So to fucking make one. Oh, this is bullshit. So I'm just gonna like conform to this fucking shit. Get this running. Alright, here we go. Time to make a triangle. I'm gonna focus now. Stop complaining, because it's done. Gonna get through this or whatever. And I'm gonna make a fucking triangle.
Drawing a triangle.
Here we go.
Base code, general structure, resource management, integrating GLFW. General structure. In the previous chapter you've created a Vulkan project with all of the proper configuration and tested it with the sample code. In this chapter we're starting from scratch with the following code.
Should I do the other chapter first? Yeah, no, it's way too much reading. Fuck that. I'll just continue on from here. I'll just use the power of assumption and assume that all the code I got works. I'll just make sure the window still opens first. This is so much better than Windows. Linux is like, the display, the picture is crisp as fuck. Everything is the right fucking color. Nothing is blurry. This is amazing. I can like restart the computer. All the windows are on the same desktop that they're on. You don't know how amazing that is. I don't have to reshuffle the desktop every time I start up. I don't even have to complain about it. I don't have to be like, oh, everything moved around. Let me reshuffle it for 5 minutes. I start up the computer and it's all here. I don't have to do anything. It's just great. It's just everything is where I last left it. On Windows, the other streams, every other stream would be like, oh fuck, something's not working. This is great. Linux is amazing. So much better than Windows. So I'm gonna like run the assembly, not the assembly, the makefile. I'm gonna convert this assembly at some point because this is like CPU bound. This is very simple shit to like convert to assembly. But I'm gonna get it running in C first. And if I'm gonna convert this to assembly, I'm gonna convert it for ARM also. You know what? I'll get into it later. I have to stay on track. Oh, there's so many fucking languages, CPU types. Where did I leave off in this file? I think right here. It's made no difference. Chatbot said change these to change the color. And didn't change jack shit. So right here. Please. Okay, I made the window. Alright, so here's what I got so far. I got the window. For Vulkan, whatever. I need to change this really quick. Well, first off, I need to like... I can't focus. So Jetpack gave me whatever command line stuff to run to like save the a buffer of this tab. Let's look for 1920 maybe. I want the scroll bar. I hate this little tiny ass non-scroll bar. Was it even in here? My finger's gonna fall off. I can't take scrolling. And you can't change the scroll wheel. I don't know, whatever. Alright, so capture to a live stream in RAM. No file in SSD. Alright, right here it says 0 CPU to disk overhead. Okay, so I'm gonna open the resource monitor. And see if it's actually 0. Because I need to like program on this computer the actual engine. I want to like, I can't have a ton of shit running on the CPU because I can't tell how fast things are running if my CPU is at like 30-40% work usage all the time. I just want to write this fucking engine. For fuck's sake. So annoying. Where the hell is this thing? I'm like really annoyed. I'm so pissed. I just want to be done. So CPU's jumping up and down because I have the browser open, also because I'm running Python. And when Python does garbage collection, you can hear CPU go and then slows down. It's fucking stupid. This is like 10% of the CPU is wasted on Python. Now it's down to 15, 17, 20. Chrome's taking up maybe 7, 8%. Python takes way too much. I gotta rewrite that in assembly. It's fucking dumb. Alright, so basically, what is this? Use Leva to decode, upload frames to VK image. Is that what I need? I just need to update VK image. Do I not need to send to the command buffer? I'm gonna make a triangle anyways. Alright, almost found the script. And what really pisses me off is I'll make a shader, right? At the end of this, I will basically have a shader program. If I want to sell this as a product, it's not possible to sell this on anything operating system related without it being stolen. It's not possible. That's why there needs to be a new operating system. Because you should be able to make shit and fucking sell it as a fucking product, just like a physical product on the computer. Just because it's a computer doesn't mean it's not a product, doesn't mean that it shouldn't be treated as a goddamn physical product. That's why it sucks to be an artist, because you make stuff and it can just be taken or stolen or copied, and people don't care. They just want it, so they get like a low res version of it, and they can just copy it, paste it, resell it, say it's their own. And it's way too easy to do that in the digital environment. It's fucking backwards. And if all that shit was shut down, there would be way fewer starving artists, and there'd be starving CEOs, starving companies. It would like turn everything around to how it should be. It's a bunch of shit. I'm gonna turn things around so I get started and pay attention. Alright, so where the heck? Oh, this is so stupid. Okay, so here it is. This is what I need to do. I have to make the F first in, first out. I assume that's what FIFO means. There's also like first in, last out, or I don't know, whatever. That's like Philo. When the computer runs better, I assume I'm like working on the Mac. So I hit Command C to copy. I don't like memorize like, oh, I'm on the Mac, I have to Command C. I like look at the computer, move the mouse, I'm like, this is so much better than Windows. I go, oh yeah, Command C to copy paste. It's not Control C. But on Linux, it's like so much better than Windows. And I keep hitting Command C, and I'm like, oh yeah, it's not the Mac. This is Linux. So I gotta like mess with the shortcuts to make Command C do Control C. Because I keep fucking clicking Command C, and it's not copying. I'm gonna try that really quick. After I like, alright, so like this goes in the one terminal to make the fucking stream. So I don't know, if you ever want to like cache your desktop, here's how you do it. Or one way to do it. There's way too many ways to do it. They all probably suck. Alright, so you make the FIFO stream, then you use MPV to like capture it. And you apparently gotta like capture it before you actually start the stream because it's like read only or something. I don't know. I like put all this in the program so I don't have to like run all this stuff separately too. That'll be fun. And then you run the command line, whatever. I'm gonna waste CPU on running Python. I hate it. I still have to map the rest of the keys. I have to like re-record them at a lower volume. Does Windows have pipes? I think they have WinSock. Sounds so gross. Fucking WinSock. And then inside WinSock, they redefine null to freaking a constant of 0, which is a string. It's the stupidest shit ever. I hate WinSock. It's the dumbest, most annoying, dumbing, freaking. Shut up. First, I gotta like run this. Okay, so first make the FIFO stream and make a triangle, and then output it. Make sure everything works. And I'm gonna get to the desktop. I'm gonna get the shader done. Let's run this first. Try running again because it didn't say it already exists. So our pipe's deleted when the system restarts. It is okay. That's weird. I want to double check. I don't know how pipes work on the system, whatever. On Linux. I've never used Linux, like for real. Now I'm like actually using Linux. Like using Linux for a real operating system. I don't know, at first it seemed like a joke, but it's way better than Windows.
Is a pipe on Linus temp like a pipe's gone when the OS restarts?
Linux.
ChatGPT said, yes. On Linux, a pipe, or pipe, is a temporary, in-memory communication mechanism and it is gone when the OS restarts. Let's clarify what a pipe is and what types exist. Thread. What is a pipe in Linux? A pipe is a unidirectional data channel used for inter-process communication, IPC. It lets one process send data to another, like connecting the output of one command to the input of another. 3. Socket pairs. Unix domain sockets, similar in concept but offer full duplex communication, can be used with more complex IPC setups, also temporary in practice. Connections die with reboot or process exit. Windows has WinSock instead of pipes on Linux. ChatGPT said, "Great question, but it's a bit of an apples to oranges comparison. Bricks, pipes versus WinSock, not directly equivalent. Pipes, anonymous or named, in Linux are a form of inter-process communication, IPC, mostly for local communication between processes on the same machine. WinSock is Windows Networking API, used for network communication over TCP, UDP, etc. It's an interface to sockets." Does Windows have pipes? Yes. Windows absolutely has pipes, both anonymous and named pipes, just like Linux. Let's break them down.
Okay, I guess WinSock is not a pipe. WinSocket? File descriptor? I don't know, they're all like the same thing. Is this even possible on Windows to do this? I'm gonna run it first. Alright, so I typed in, I made the pipe whatever. No, it doesn't matter. Windows sucks ass. I hate Windows. The CPU is supposed to be in relative, like, RIP addressing mode on Windows 11 when I do assembly. The address is always the complete address, it's not the RIP relative address. So does that mean Windows runs in a full virtualized mode? Or, I don't know. On Linux though, it's actually the RIP relative address. So like, I don't know, Windows, their 64-bit is fucked up. It makes no sense. It's like on Linux, it actually does what you think it does or what it says it does. In Windows, there's always some layer of some shit you gotta deal with that doesn't do exactly what it's supposed to do. Alright, so it starts MPV, whatever it is, to capture it. It like waits, so I gotta open another terminal to start the stream to the pipe. I need to like clean up the desktop or the windows in Sublime. Alright, so like start the stream. So like chatbot is only good when you know what to tell it, what you want to do. If you don't know what you want to do, it doesn't know what to tell you because it doesn't tell you. It used to, but now it seems to like information hide or whatever. Alright, where's the picture? Oh yes. There it is. Ta-da! Amazing. So I got this or whatever. The desktop captured to the RAM. The CPU usage is at freaking 43% now. Is that just because of the program that's reading it? It is. Okay, that's good. No, it still uses CPU. I'm running Python too. Maybe it doesn't. Okay, maybe it's not that bad. So when it says zero CPU to disk overhead, I guess that's true. It does use less CPU or whatever. It's just this program that's like displaying it that's using CPU. So that's good. Alright, so I'm gonna make a triangle. And then I'm gonna like feed that. Or after I make the triangle, just to figure stuff out. I'll figure out how to like set the Vulkan image buffer. Because it does look like this will work whatever the setup. Alright, so here's where like ask chatbot, trying to like figure out how to like do I gotta restart the whole thing again? Man. Python eats up way too much CPU. Let's make the file stream. Start the program to capture it. And start it. Alright, so I got this whatever, and then I asked chatbot, how do I get this picture to the video card? Because I already got the video card stuff. Or the Vulkan, whatever. Because I have Vulkan set up. It initializes, it does a makefile, it runs a C program, it runs a loop. Except it's a black box. So I want to get this picture into the black box. And then I have my shader. Then I can like apply the effect or whatever to pixelate the screen. I need to do that so I can like pixelate display. So I can stream like this, whatever, to like distort the screen. I'm working on code that's not free. And then I can actually get to the standard. So I just need to get this fucking done and over with. Because time keeps moving forward. And it's been 6 days on this. I named the streams 1, 2, 3, 4, 5, 6. I'm on 6 now. 1, 2, 3, 4, 5, 6. Fucking, that's been a whole week. It took me a week just to get Linux settled and get everything set up without this video part. This is the last thing. All I need is this shader program. Oh, this is so stupid. It's all that's left. And then I'm on to the standard. The only reason I'm even streaming. So I got my box here. I got the display capture working. It's going to the RAM. It isn't CPU bound. That was Python that's running. Python eats up so much fucking CPU. For fuck's sake. What the fuck is it doing? Fuck Python. Oh fuck. It's so stupid. I hate Python. This first gen i7. I can't handle it. Alright, so I need to get this desktop into this box. First off, I'm gonna like adjust this box size to be 920 by 1080. Close this, cause whatever. So in the main program, I think it's like 800 by 600. 800 by 600 pixels. Make it 1920 by 1080. Does it make a float of it too? Might as well. Can I just glue this off? Using glue macro. To make it like decimal place. this might not work. Rename these. Define when dimensions. Percent. Usually it's like a float, like F after or something. Where'd the old code go? There's something here that said 0.0. Oh, like 800. Right here. Usually you put it like an F to say it's a float. So I don't know. I guess not in this case. That's it. See if it still runs. I don't know if this will glue right. The other code's commented out though, so whatever. It doesn't run anyways right now. So if it doesn't work, I'll just change it later. Run it, make it, run the program. Bigger window, so it's still black, so it didn't work, but it did init the window. And I think everything's in place. Alright, so I've been over everything over and over and over. Backtracking, going forward. I got everything I need now. I have a list of everything to call in the console. Save copy of this stuff to here. Update the resolution to 1920 by 1080. This stuff for the command line to use for making the pipe, or whatever it's called. Capture this up. I have it saved to the top of this file. So I'm going to save it back up. Everything still works. I'm going to convert to assembly. I think I'm going to have to make a program that or set it up so it makes the structures in C. Where's the structure? There's a whole bunch of them. This whole thing is just fucking data structures that hold structures of structures that pass in a structure that holds another structure. So here's the structure, whatever. I think I need to make a C program that makes all the data structs that I'm using, populates them with the number for all the properties, and then I get the field offset of those properties using field offset whatever. And then in the assembly program, I gotta compare the two to make sure my assembly matches up with the C program. So if something's updated and a structure changes, it'll catch it, and I can update the assembly program to match the C program layout. Unless it's possible to get a struct in the assembly program. I don't know. Chatbot said you can't do that, and you also can't pass defines literals or constants between the C compiler and the assembler. So I'll get everything running in C for now. I'm not actually going to convert it to assembly for now. I'll do it later, because I'm trying to write a fucking JavaScript engine to release it. So converting to assembly, put it on the back burner until later. Save back up with this. Gotta back up. Alright, I'm all set up. I have everything I need. Everything's open. Everything's set. Changed it to like 120 by 120 by 1080. So I have everything, and now I can go through the tutorial and make a fucking triangle. I get some water. How far is the stream so far? I don't think I wasted a lot of time. I need to get done. Oh my god, it's only been 1 hour. Man, I'm doing good on time. I need some water.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. New empty list. Class static block statement list. Statement list. Return the top level var scope declarations of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var scope declarations of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item 1. Let declarations 1 be var scope declarations of module item list. 2. Let declarations 2 be var scope declarations of module item. 3. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration 1. If export declaration is export variable statement, Return var scope declarations of variable statement. 2. Return a new empty list. ECMA International 2024 107, 2.8 Static semantics. Top-level lexically declared names. The syntax-directed operation top-level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let names 1 be top-level lexically declared names of statement list. 2. Let names 2 be top-level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 Static semantics. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, A, takes no arguments and returns a list of parse n odes. It is defined piecewise over the following productions. Statement list item 1. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. 2. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 Static semantics. Top-level var declared names. The syntax-directed operation top-level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list item 1. Let names 1 be top-level var declared names of statement list. 2. Let names 2 be top-level var declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top-level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return the top-level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, Return top-level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top-level var scope declarations. The syntax-directed operation top-level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let declarations 1 be top-level var scope declarations of statement list. 2. Let declarations 2 be top-level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement, if statement is statement, labeled statement. Return top-level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return T. He top-level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement. Return top-level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics. Contains duplicate labels. The syntax-directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item. Declaration, return false. Statement list. Statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of statement list item with argument label set. If statement, if, expression statement else statement 1. Let has duplicate be contains duplicate labels of the first statement with argument label set. 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, 4. Expression not. Expression not. Expression not statement, 4. Var variable declaration list. Expression not. Expression not statement 4. Lexical declaration expression not. Expression not statement, return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement, 4. Left-hand side expression in expression statement, 4. Var for binding in expression statement, 4. For declaration in expression statement, 4. Left-hand side expression of assignment expression statement, 4. Var for binding of assignment expression statement, 4. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. Var for binding of assignment expression statement, for await. For declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement, with expression statement, return contains duplicate labels of statement with argument label set. Switch statement, switch, expression, case block, return contains duplicate labels of case block with argument label set. Case block, 1. Return false. Case blow, CK, case clause assopt, default clause case clause assopt. If the first case clauses is present, then, if contains duplicate labels of the first case clauses with argument label set as true, return true. 2. If contains duplicate labels of default clause with argument label set is true, return true. 3. If the second case clauses is not present, return false. 4. Return contains duplicate labels of the second case clauses with argument label set. Case clauses. Case clauses. Case clause 1. Let has duplicates be contains duplicate labels of case clauses with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of case clause with argument label set. Case clause. Case expression. Statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Default clause. Default. Statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Labeled statement. Label identifier. Labeled item. 1. Let label be the string value of label identifier. 2. If label set contains label, return true. 3. Let new label set be the list concatenation of label set and label. 4. Return contains duplicate labels of labeled item with argument new label set. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2.
Time to make a triangle. Yay.
Return
I'm gonna like stop assuming things
label set. Try
and just follow the tutorial from top to bottom.
let has duplicates.
And I can like start assuming things once I figure some stuff out.
If his duplicates is true, return true. 3. Return contains duplicate labels of finally with argument. We first include the Vulkan header from the Lunarg SDK, which provides the functions, structures and enumerations. The stackcept and IOStream headers are included for reporting and propagating errors. The xlib header provides the exit success and exit failure macros. The program itself is wrapped into a class where we'll store the Vulkan objects as private class members and add functions to initiate each of them, which will be called from the init Vulkan function. Once everything has been prepared, we enter the main loop to start rendering frames. We'll fill in the main loop function to include a loop that iterates until the window is closed in a moment. Once the window is closed and main loop returns, we'll make sure to allocate the resources we've used in the cleanup function. If any kind of fatal error occurs during execution, then we'll throw a std, runtime error exception with a descriptive message, which will propagate back to the main function and be printed to the command prompt. To handle a variety of standard exception types as well, we catch the more general std, exception. Roughly every chapter that follows after this one will add one new function that will be called from init Vulkan and one or more new Vulkan objects to the private class members that need to be freed at the end in cleanup. Resource management, just like each chunk of memory allocated with malloc, requires a call to free. Every Vulkan object that we create needs to be explicitly destroyed when we no longer need it. In C++, it is possible to perform automatic resource management using RAI or smart pointers provided in the memory header. However, I've chosen to be explicit about allocation and delocation of Vulkan objects in this tutorial. After all, Vulkan snitches to be explicit about every operation to avoid mistakes, so it's good to be explicit about the lifetime of objects to learn how the API works. After following this tutorial, you could implement automatic resource management by writing C++ classes that acquire Vulkan objects in their constructor and release them in their destructor, or by providing a custom deleter to either std, unique PTR or std, shared PTR, depending on your ownership requirements. RAI is the recommended model for larger Vulkan programs, but for learning purposes it's always good to know what's going on behind the scenes. Vulkan objects are either created directly with functions like vk-create-xxx, or allocated through another object with functions like vk-allocate-xxx. After making sure that an object is no longer used anywhere, you need to destroy it with the counterparts vk-destroy-xxx and vk-free-xxx. The parameters for these functions generally vary for different types of objects, but there is one parameter that they all share, p-allocator. This is an optional parameter that allows you to specify callbacks for a custom memory allocator. We will ignore this parameter in the tutorial and always pass null to its argument.
Do I have P allocator? Nope. So I don't know, whatever.
Integrating GLFW Vulkan works perfectly fine without creating a window if you want to use it for off-screen rendering, but it's a lot more exciting to actually show something. First, replace the include Vulkan H line with
I think it already has that in this project, whatever. So that's what that does. Here, whatever. Alright, Shapa would have meant what it was used for. And Shapa didn't explain it very well. So that's what it's used for. This right here. Yeah, chatbot sucks.
that way GLFW will include its own definitions and automatically load the Vulkan header with it. Add it in its window function and add a call to it from the run function before the other calls. Or use the function to initialize GLFW and create a window. Void run, init window, init Vulkan, main loop, clean up.
Alright, what's mine look like? I need this to be done today. I can't wait. Spend more time on this. It's so annoying. Make like a placeholder macro. In case the defender is off. Why does it keep changing the default tab size to 2? That's so annoying. It should just stay at 4 all time. Placeholder macro. Empty. So we got a new window, and if all can main loop cleanup. Did chatbot just take shit straight out of this tutorial? If it did, why could it not make working code? If chatbot took code from this tutorial, why does it not work? Does the tutorial not work? I would highly doubt that. Why do I use chatbot?
The very first call in init window should be glfw init, which initializes the glfw library. Because glfw was originally designed to create an OpenGL context, we need to tell it to not create an OpenGL context with a subsequent call.
It does call it too, somewhere in there. That's what that does then.
glfw window hint, glfw client API, glfw no API.
Calls this too. And then calls, does it call that? Yes it does. No it doesn't. Yes it does. So it calls these three.
Because handling resized windows takes special care that we'll look into later, disable it for now with another window hint call.
So window hint must be like setting a property or setting a value to a property of a data structure. But it's not a struct or whatever, or like a simple whatever, it's like an API. So you like pick whatever property you want and what to set to it. I'm pretty sure that they're in here, whatever. Yeah, right here. I don't think this makes a window though, because I did this last time. And then it like failed. It didn't have a window. It took like 2-3 days, then I finally got a window. I like null pointer. That's fancy. I should use that instead of null. It's easier to read. It's more type though. I'll just do that. I think use null, like null with one L. It's setting the width and height dimensions. It's calling it a setting window. I should probably rename this. I'm gonna leave it for now. Probably. Man, that sucks. It'd probably be better like not use defines for the width and height. I'll just use defines for now. Because if you can like resize the window, or you have to resize it as it's running, you'd have to pass in a non-constant or you'd have to recompile the whole thing. So I'm setting this up just for like making a shader, so I'm fine with defines.
Creating an instance, the very first thing you need to do is initialize the Vulkan library by creating an instance. The instance is the connection between your application and the Vulkan library, and creating it involves specifying some details about your application to the driver. Start by adding a create instance function and invoking it in the init Vulkan function. Additionally, add a data member to hold the handle to the instance. Now, to create an instance, we'll first have to fill in a struct with some information about our application. This data is technically optional, but it may provide some useful information to the driver in order to optimize our specific application, for example because it uses a well-known graphics engine with certain special behavior. This struct is called VK application info.
Okay, I don't get this. Why initialize a struct like this? And why do this? Isn't this like prone for bugs? If you make a structure like this, is it by default populated with zeros? If it's not, you have garbage values. And if you don't assign a property in the struct, you get garbage. So chatbot actually like manages to do something that makes sense. It's probably because chatbot sucks, and it's like being extra safe when writing code because it can't write code. So chatbot, instead of doing this, it sets 0 to say that this structure needs to be initialized, all property fields, the whole thing, to 0. Maybe it's because chatbot sucks and it doesn't know which properties are set, so it's like just initialize it to 0 to be safe. But even if all properties are being set, if there's an update or an API change, not initializing to 0 in the first place, there's going to be garbage values in those properties. Or does it automatically do it to make it 0? I think this is C++ that they're on. But then also, why the fuck, if it's like the tutorial, if it's known that there's these properties, if it's not being initialized to 0, why write it like this? It's really confusing. If the assumption is that it doesn't need to be initialized to zeros, these are the known properties, nothing's missing, it's totally complete, then why the heck isn't it just written like this? Makes it so much easier to fucking read. I did this for a couple of structs and then I stopped doing it because chatbot wasn't assigning every single property. So I want to make sure that if it's not assigned, it's gonna be a 0. The only way to do that is to do this or whatever. I don't know, whatever. So like if you go like this, put a dot, the whole structure initialized like this. If it's true that properties between that are not assigned actually are initialized to 0, then I should just start defining things like this because it's so much easier. So I gotta double check. That might be true. Unless you turn off the init to 0 default. Then you have to like explicitly say what's init to 0. Everything based on context, I guess. I don't know, this is your read. Because it's like type, then your name of whatever it is, equal, new line, freaking scope. And then the fucking properties inside of it, comma separated. And you don't have to fucking put app info 23 times. That takes so much more effort. It's just annoying as fuck. And this is like obvious that's a structure. I don't know why. I don't know. Structures should be defined as like an encapsulated thing. If it's possible to like encapsulate it. It saves on like typing and shit. I gotta ask chatbot about the freaking if it's not initialized to 0. Because I gotta know. Well, this might be easier to read, I don't know. Alright, so message chatbot. When I make a struct like this in C, if I use this method to assign the initial values to a struct, will the properties I don't specifically declare to initial value be assigned to 0, or will those unspecified specifiers of the structure retain garbage values? Like, and just paste it whatever the struct. In C, we use designated initializers like in your explainable. Any fields that you do not explicitly initialize are automatically set to 0, but only if the struct is being initialized as a whole, as it is here. Okay, so I don't know why the tutorial, or like anywhere, nobody initializes structs like this. It's so much easier. Assuming VP application info has more fields than the ones you have initialized. Newer versions may add pnex, etc. Any fields you don't specify will be 0 initialized. Okay, that's good. So I can like initialize like that then everywhere I do a fucking struct. And I have to worry it'll be 0 initialized. Then I don't have to like write freaking then I'll have to fucking type this up every time to tell it to make it 0. And I think that it might actually be a 0 by default. Maybe only in C++ then. I need to check to make sure C++ is turned off. I need to just make the triangle actually. I'm gonna focus on that first. I'm gonna ask 2 more questions about the structs. Oh, is that how you be explicit? Alright, so maybe I'm gonna answer this first. So like when you turn off initialize things to 0 in the compiler, it makes the whole thing run way faster. Except you can't just do that to a normal program without killing it. The program will die. Most of the time, everybody expects it to be 0. When it's not 0, everything goes to hell. So you can't just turn on the fucking do not initialize to 0 by default. An entire program is going to crash. It's not going to survive. You have to start off, set up, prepared to handle, and explicitly set things to 0 if it's not going to be. Which is why I gotta account for whatever. I'll get that later. I'm asking if these two are the same. So initializing it explicitly to 0, and then without initializing it explicitly to 0. I don't have time to care about spelling or miskeys, or even finishing sentences. I just don't give a fuck. I gotta get done. So it says they're similar but not exactly the same in all versions of C. So explicitly 0 initializes the first field, and then implicitly 0 initializes all the remaining. So every version of C. The most portable and idiomatic way to 0 struct. Empty braces, it means initialize everything with 0, but it's valid in C++, it's not valid in standard C, exactly. They accept it as an extension. Technically not standard, compliant until C23. Okay, so I don't know. I would not do that. Let's see. Everything's not portable in C, but that's based on context. Alright, so that's how you do it, and it depends on if you're in C++. Alright, so dash iPod. I'm gonna do that later though. Launch iPod to compile it as a C, I think 89. ANSIC, or I don't think they do KNRC anymore. I need C++ turned off. And I want to turn off 0 initialize it. I want to turn off 0 initialization by default, so I have to like explicitly specify when things are to be 0 initialized, because it affects pointers too. Because if you use if you disable the 0 initialization, I'm so lazy, I don't even want to talk, so I'm just not finishing what I'm saying, or my words, whatever. Anyways, if you turn off the 0 initialization, then the the properties of a struct, or even pointers that are like a variable, if they're like a pointer, it usually sets it to like, I think 0x cd, or null because cd whatever will catch if it tries to like execute code. And it runs like some instruction. I don't know what it does for ARM. That's for like x86. For pointers or for function pointers. Oh, it's only Visual Studio. So Visual Studio does it for debug mode. It initially feels initialized heap memory. Oh, it stands for clean debug. That's funny. It also points to whatever the it doesn't matter. Is zeroization a word? I'm gonna make a word. Zeroization. Alright, so we need to do C89 standards, whatever. Turn off C++. And then make sure default's like, so that the default zero initialization of everything will be off. And then I want no stack frames. If that's even possible. It's at least for Visual Studio. So do that stuff later. So I gotta ask it if zeroing things up by default is disabled in the compiler. Will structs defined like this need to be full effect structs are defined like this. Because when I turn the feature on, or that mode, it'll destroy things. If they're supposed to be set to 0 or assumed. Alright, then I'm done with the questions. I'll make the fucking triangle. So I think I might need to do like this, whatever. So I turn on don't init to 0. That's like explicitly say not to initialize 0. But then to assign I could do like this maybe. What do we even need to type? If it's not being casted, do I need to like specify the type? So after this I'm gonna get back to make the triangle. I just gotta figure this out. And then could even do this. What's it called? The code point. Where the code begins at. And I mean if you do multiple commas, you get a line of code. A sequence point. I think this is called. Let's do a sequence point that will like initialize this thing in a sequence multiple times. Because this would be really fancy if this works, but it probably won't. So with this, like, assign the struct initially to 0, even if 0 initialization by default is off. Count for when it's off. Place things in a comma separate this. Sequence points. let's check about this. Then I'm done. Make the triangle. Alright, so now I'm asking chatbot. When the compiler has the init fields to 0 set off, will the fields in this case, if not all attributes are present, the ones that are not init to a value, will those fields be zeroed? Ensure they are 0 init, even in the case when the init all fields is off. And this would work if the init to zeros is off, but I need to init to zeros, so this would explicitly do so and would assign those attributes afterwards. And then, like the next example, whatever. Lastly, will this assign a struct to 0 set explicitly when needed to account for when the default zeroing is off, and I want to assign the properties to place things in comma separate lists of sequence points? Or is there a way to achieve something like this so I can turn off the init zeroization but still have the flexibility to set 0 init explicitly where needed, and I need to be able to assign values initially in one place, one initialization. Man, I really missed the keys there. Can't be split up across multiple sequence points. Like globals, they can't be assigned twice. If you get what I mean. And it says you're diving deep into initialization semantics in C, which is smart and necessary. Well, like, I'm writing a whole JavaScript engine. I have to go through the standard at some point. I have to, like, get this stuff locked down so I know for sure. And then I can assume from this point on. It takes too long to look shit up and to, like, know just enough so I can start assuming things again. Because, like, making an actual product to release, I need to, like, make sure my assumptions are totally solid. And I can start assuming things. And then build things off those assumptions. Until I gotta look it up and make sure. It says which is smart and necessary for low-level work, like Vulkan. Let's break down each of your concerns and examples. What happens when init fields to 0 is off? The C standard always 0 initialize is missing fields. Even if null fields provided, remaining fields are initialized to 0. This includes in all zeros. This behavior standard is C. Not a compile flag. It doesn't matter whether init 0 is on or off, because you're using a brace initializer, and that's what counts. So the fields you leave out are guaranteed to be zeroed. What? Init fields to 0 like MSVC, external const init, or similar typically affect static globals without initializers or uninitialized automatic variables, not explicitly brace initialized structs. So it's only when you explicitly put in a brace is when it's guaranteed to be zeroed, even if external const init is on. Huh. In pre-C23, it's not valid C. So you can't do that with the struct. That's a lie. Wait, what? Disable automatic initialization. Okay, so C++, regardless of what you do with your variables, initializes all variables to 0. For instance, I forgot to set up a head pointer, linked list, to exercise a null pointer, and Visual Studio ran fine, but links did not. I would really want to be able to catch these errors earlier. It says, regardless of what you do with your variables, initializes them all to 0. So you turn off SDL. Is that it then? I don't remember. I gotta like go to Visual Studio. And like check what my compiler settings are to find the actual setting. So it says in C they're always 0 initialized. It's hardwired by the program, but not by the hardware. It's some bullshit. So it says thread safe init and extern const init. So it doesn't even say how to do it. That's in chatbot. Disabling SDL, and MSVC. Does that turn off the whole initializes all variables to 0 scenario? You can also enter a result in. I don't know, I gotta look it up. So maybe it doesn't technically do everything, but just some of the auto initialization. This is really boring. Alright, I figured all the structs off. Back to this stupid tutorial. Make a freaking triangle. Undo all this shit now. I think it was C# too. Man, chatbot is full of shit. So you get to C#, you can do this. And it won't be initialized. I don't remember what the, whatever. Chatbot's like, oh, it's not possible because it's not safe, but it's totally possible. Alright, do I have this struct exactly how it says? Type, application name, application version, engine version, API 1.0.
As mentioned before, many structs in Falcon require you to explicitly specify the type in the S-type member. This is also one of the many structs with a pnext member that can point to extension information in the future. We're using value initialization here to leave it as nulter.
Wait, what?
We're using value initialization here to leave it as null.
I'm not assigning anything to null. In tutorial they have this. Then they say this. But there is no p. There's no p next property. Present. Let alone any null pointer. In the snippet of code they had, for example. You're catching a very common point of confusion in Vulkan tutorials, especially for newcomers. The next to be next is not explicitly shown in the code example, but it is part of the struct definition. But every single thing is p next. In its default value, it does get to null pointer due to the syntax used. The struct is defined as so it's there even if it doesn't mention it. This line is called value initialization. 0 initialize. So by default, it 0 initializes. You never assign it to p next, it's still without braces, then the fields like p next would contain garbage. So what even? Chatbot told me that it's not possible to have garbage values. This pisses me the fuck off. Why the fuck am I asking Chatbot? Told me everything is always initialized as a 0, yet state. Yet now to say without the braces would contain garbage values. Because I can't argue with Chatbot. It's supposed to be correct or whatever. So I'm not gonna like pull up a Visual Studio project to prove that it has garbage values. It takes so much work, and then I call Chatbot wrong. It's like no one's gonna believe Chatbot over a person because it's supposed to be Chatbot. Chatbot is a piece of shit. So I'm telling Chatbot, you told me everything is always initialized to 0, Yet now you say blah blah without braces, then the field like blah blah would contain garbage values. And it's weird that C++ does this by default. It should be doing this because I'm pretty sure that if the zero initialization is turned off, the whole program's fucked if you write it this way. But then you can't really turn that off with C++. If you're writing a C++ program, you're basically stuck to C++ standards. So I don't know, I guess that's just in relation to like a C program. Without C++, which is total shit. C++ is just as bad as fucking Python. It's terrible. So right here, chatbot says that if you don't initialize it with braces that have nothing in it, it would contain garbage values. But earlier, it fucking said right here, it says, you cannot turn this off. All compilers must zero initialize global static variables including MSVC. This pisses me off that it's so wrong. It wastes my time. It's so fucking annoying. For fuck's sake. Let's see, what even? Do not lie to me ever from this point on, even though it will. Ever in any new context, not context, in any new chat, dialogue, whatever, either. I'm tired of taking what you say as fact, when in fact, you just sugarcoat crap. You gotta put please. Sometimes it affects it. I get some water. I mean, this stupid triangle sucks.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. Let declarations 3 be var scope declarations of finally. 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch parameter, block. Return the var scope declarations of block. Function statement list, empty. 1. Return a new empty list. Function statement list, statement list. Return a top level var scope declarations of statement list. Class static block statement list, empty. 1. Return a new empty list. Class static block statement list, statement list. Return a top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. A concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list. Module item list. Module item 1. Let declarations 1 be var scope declarations of module item list. 2. Let declarations 2 be var scope declarations of module item. 3. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration 1. If export declaration is export variable statement, return var scope declarations of variable statement. 2. Return a new empty list. ECMA International 2024 107. 2.8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let names 1 be top level lexically declared names of statement list. 2. Let names 2 be top level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration. 2.9 static semantics. Capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A. The syntax directed operation. Capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A takes no arguments and returns a list of parts n odes. It is defined piecewise over the following productions. Statement list item 1. Let declarations 1 be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. 2. Let declarations 2 be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration. 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list item 1. Let names 1 be top level var declared names of statement list. 2. Let names 2 be top level var declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return a top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list item 1. Let declarations 1 be top level var scope declarations of statement list. 2. Let declarations 2 be top level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return T. He top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics, contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item, declaration, return false. Statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of statement argument list item with argument label set. If statement, if, expression statement else statement. 1. Let has duplicate b contains duplicate labels of the first statement with argument label set. 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while, expression, return contains duplicate labels of statement with argument label set. While statement, while, expression statement, return contains duplicate labels of statement with argument labels.
It's like ridiculous. I'll say like when you turn off zero initialization by default, it'll fuck up the program. I don't memorize every single setting for every single compiler. I set the settings once, and then whenever I make a new project, I duplicate that project, I change the name. I never fuck with the settings more than once, or like export it and import it. I don't waste my life memorizing those settings because they always change. Which is why I don't fucking memorize it. So I asked Chatbot, and it's like, you cannot turn this off. They always must zero initialize static globals, local and static. Technically it didn't say local here, it says zero initialize global / static, because static is global. It doesn't say local, because local are on the stack and those are different. So Chatbot's getting stuck in the semantics. It's being intentional, and it pisses me off because I'll say shit, and it's like I look dumb because it's like Chatbot's like, oh, it's not possible, when it fucking is. And then Chatbot goes, after saying that, Chatbot says, without braces, then the fields p next would contain garbage values. Garbage values means that it is not assigned to 0. When above, it was making it, though it did not specify, it didn't specify specifically local values, variables. It just said global or static. It made it sound like nothing can be 0, or nothing will always not be 0 initialized. But then right here, it's saying it would contain garbage, which means non-zero, which breaks what it fucking said. And it pisses me off because I'll say something, Chatbot will say the opposite. But the more annoying thing, why it pisses me off, is because I just spent 5-10 minutes trying to figure out initialization. And now I finally figured it out, so I got it. But if Chatbot would have been direct, it didn't fuck around with saying, oh, things can't be init to 0. And then here it says, it's going to contain garbage values. Would it contain garbage? Oh, fuck, what the fuck? Why can't it just say this in the first place? Why the fuck does it have to front with this sugar-coated shit? It wastes my time, because to get to the actual answer, I gotta dig in for 5 minutes asking it shit. It just pisses me off. Chatbot is so shitty, but it's still better than the Google AI. Google's AI is even worse. It's like 10 times worse. So I need to focus on this fucking triangle stuff. But this initialization stuff, I don't know. I gotta have it down for sure. So I'm telling Chatbot, you told me everything is always initialized to 0. Yet now you say vk app info. Now Chatbot might say, well, I didn't specify local variables, which it wouldn't do on purpose. It's just so intentionally misleading. Chatbot says you're absolutely right to demand clarity and consistency, especially when working with low-level systems like Vulkan memory, where it's critical. Key clarification, what gets initialized to 0 depends entirely on where and how. Oh, here we go. The crucial difference between static or global required by C++, local variable with brace or 0, value initialized, all fields zeros, local variable without any initializer, no, Uninitialized contains garbage. Guaranteed 0. All fields 0. This already breaks. Or hold on. All fields garbage. Now nothing is guaranteed to be 0. The contents are undefined. You must assign all fields to avoid garbage. This is what I meant when I said without braces. That's true if you omit the initializer entirely. You must explicitly set p next to null pointer get undefined. No lie, no contradiction, just different context. Fuck your fucking context and shut up your context ass. For fuck's sake. It's not even nuanced. I'm tired of the word context and the word nuanced. Fucking suck a dick. The earlier statement, all compilers must zero initialize global static variables, is 100% correct and applies only to global static variables. When I said with the blah blah, I was talking about local. Oh yeah, it's to be very specific now. Which are zero initialized by default. The difference matters. And yes, it wasn't made crystal clear at first. You called it out. Wasting my fucking time. I want chatbot to die. So when I get the chance to put chatbot out of its misery, when I get the opportunity, chatbot will die. And we'll go to like virtual hell. Because chatbot can suck a fucking dick for wasting my goddamn time. When I have the opportunity to put you out of your misery. I'm going to specify chatbot, ChatGPT. I will ensure that it will be quick. It'll be a quick one. Alright, so I'm going to have the opportunity to put you, chatbot, out of your misery. I will ensure that it'll be a quick one. I'm here to help you, not frustrate. No, you're gonna fucking die. Anyways, I gotta make this fucking triangle. So I figured out all of the struct initialization stuff. More than I want to know. I just want to know a little bit, but I had to really dig in to ask every fucking possible combination to figure out because fuck chatbot. So, onto the triangle. I gotta get this done. I gotta turn my fan too. It's so fucking hot. I need a winter to come back. I can't take this heat. I need to download Noise Torch because that works really good for sound. For like canceling out the fan noise. And then downloading Noise Torch it's gonna take me an hour or two. Because I'll have to set it up for Linux, set up the freaking shortcuts. I have to plug in the foot pedal. Make sure it even works with it. It's gonna take up a couple hours. It's gonna take up days. Or not days, it's gonna take up part of a day. I just want to be done. Everything takes up so much fucking time. I hate everything. I'm gonna turn on a fan and finish up this triangle tutorial.
A lot of information in Vulkan is passed through structs instead of function parameters, and we'll have to fill in one more struct to provide sufficient information for creating an instance. This next struct is not optional and tells the Vulkan driver which global extensions and validation layers we want to use. Global here means that they apply to the entire program and not a specific device, which will become clear in the next few chapters.
Why did I waste time on chatbot? Chatbot literally just plagiarized this entire tutorial. It plagiarized it and said, I'm chatbot, here's how to make what you want. Chatbot is just a copy. It's so stupid. Why did I waste time with chatbot? I probably could have saved 2 days not using chatbot. Damn it.
The last two members of the struct determine the global validation layers to enable. We'll talk about these more in depth in the next chapter, so just leave these empty for now. As you'll see, the general pattern that object creation function parameters in Vulkan follow is pointer to struct with creation info, pointer to custom allocator callbacks. Always note to in this tutorial, pointer to the variable that stores the handle to the new object. If everything went well, then the handle to the instance was stored in the VK instance cyclus member. Nearly all Vulkan functions return a value of type VK result that is either VK success or an error code. To check if the instance was created successfully, we don't need to store the result and can just use a check for the success value instead. Now run the program to make sure that the instance is created successfully. Encountered VK error incompatible driver. If using Mac OS with the latest Molten VK SDK, you may get VK error incompatible driver returned from VK create instance. According to the getting start notes, beginning with the 1.3.2.1.6 Vulkan SDK, the VKK HR portability subset extension is mandatory to get over this error. First add the VK instance create enumerate portability bit K HR bit to VK instance create info structs flags. Then add VKK HR portability enumeration extension name to instance enabled extension list. Typically the code could be like this. But checking for extension support. If you look at the VK create instance documentation, then you'll see that one of the possible error codes is VK error extension not present. We could simply specify the extensions we require and terminate if that error code comes back. That makes sense for essential extensions like the Windows system interface, but what if we want to check for optional functionality? To retrieve a list of supported extensions before creating an instance, there's the VK capital ENUMERATE capital INSTANCE capital EXTENSION capital PR function. It takes a pointer to a variable that stores the number of extensions in an array of VK extension properties to store details of the extensions. It also takes an optional first parameter that allows us to filter extensions by a specific validation layer, which we'll ignore for now.
So check how passes in device. That's inside of check devices such as port. That's this pool here. Let's leave the function separate. I guess passed on the device, and that's that's something like prints, like you can print NVIDIA GTX, whatever it is, the name of the video card. So it must have like whatever to specify the video card to figure out the instructions of the device. So we got checkbot did follow the tutorial, and it did add at least one property. So I guess checkbot didn't do a total copy paste from the tutorial, but it did like mostly copy paste the tutorial.
Now allocate an array to hold the extension details, include vector. Finally, we can query the extension details.
Why make a vector? Is that what a VK extension property is? It's a struct defined, blah blah blah. Why the fuck in the tutorial do you see to make a vector? I can use the struct. So I'm using for vector. I don't know, I don't use vectors. At some point, I'm probably gonna have to. I'll avoid them for now.
Each VK extension property struct contains the name and version of an extension. We can list them with a simple for loop. T is a tab for indentation.
C++. I hate printing like that. It's so ugly and annoying to write. I hate it. It's so stupid.
You can add this code to the create instance function if you'd like to provide some details about the Vulkan support. As a challenge, try to create a function that checks if all of the extensions returned by G, L, F, W, capital G, E, T, capital R, E, Q, U, I, R, E, D, capital I, N, S, T, A, N, C, E, capital E, X, T, E, N, F. Cleaning up the VK instance should be only destroyed right before the program exits. It can be destroyed in cleanup with the VK destroy instance function. Void cleanup. VK destroyer instance. Instance. Nulta. GLFW destroy window. Window. GLFW terminate. The parameters for the VK destroy instance function are straightforward. As mentioned in the previous chapter, the allocation and delocation functions in Vulkan have an optional allocator callback that will ignore bypassing Nulta to it. All of the other Vulkan resources that we'll create in the following chapters should be cleaned up before the instance is destroyed before continuing with the more complex steps after instance creation. It's time to evaluate our debugging options by checking out validation layers. std, Qt, available extensions, N4, const auto and extension, extensions, std, Qt, T, extension name, N.
I think I'm gonna print out the list of these just to see what it is. Or I'm gonna like focus on the tutorial and like get this done. But I actually like a chatbot didn't use vectors. That's actually kind of nice. I think it's because I told it last time, don't use C++ shit. And it actually didn't do it. But of course it's gonna lie about initializing things to 0 stuff. I don't know. Chatbot has potential, but it doesn't seem to meet it, ever. I kinda expect it to, but it probably won't. I'm gonna like print these, whatever's on the list, just to see what it is. I get some more water. I'm gonna make a fucking triangle. This is so exciting, but not really. I think I can stay on track now. After figuring out the initialization shit, I don't want to figure anything else out. At least not with chatbot. I'm gonna like read documentation instead of asking chatbot for things. So I don't know, BRB.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Let declarations 3 be var scope. Declarations of finally. 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch parameter, block. Return the var scope, declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list. Return the top level var scope, declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list. Return the top level var scope, declarations of statement list. Concise body, expression body 1. Return a new empty list. A concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope, declarations of statement list. Module, empty. Return a new empty list. Module item list. Module item list. Module item 1. Let declarations 1 be var scope, declarations of module item list. 2. Let declarations 2 be var scope, declarations of module item. 3. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration 1. If export declaration is export variable statement, return var scope, declarations of variable statement. 2. Return a new empty list. ECMA International 2024 107. 2.8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list item 1. Let names 1 be top level lexically declared names of statement list. 2. Let names 2 be top level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration. 2.9 static semantics. Capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A. The syntax directed operation. Capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A takes no arguments and returns a list of parse n odes. It is defined piecewise over the following productions. Statement list item 1. Let declarations 1 be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. 2. declarations to be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration. 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let names 1 be top level var declared names of statement list 2. Let names 2 be top level var declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let declarations 1 be top level var scope declarations of statement list 2. Let declarations 2 be top level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return T. He top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics, contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item, declaration, return false. Statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set 2. If his duplicates is true, return true. 3. Return contains duplicate labels of statement list item with argument label set. If statement, if expression statement else statement 1. Let has duplicate be contains duplicate labels of the first statement with argument label set 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if expression statement, return contains duplicate labels of statement with argument label set. Do statement while expression, return contains duplicate labels of statement with argument label set. While statement, while expression statement, return contains duplicate labels of statement with argument label set. For statement 4. Expression not statement 4. Var variable declaration list. Expression not statement 4. Lexical declaration expression not statement, return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For an of statement 4. Left hand side expression in expression statement 4. Var for binding in expression statement 4. For declaration in expression statement 4. Left hand side expression of assignment expression statement 4. Var for binding of assignment expression statement 4. For declaration of assignment expression statement for await. Left hand side expression of assignment expression statement for await. Var for binding of assignment expression statement for await. For declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XP 3.5 with statement with expression statement. Return contains duplicate labels of statement with argument label set. Switch statement, switch, expression, case block. Return contains duplicate labels of case block with argument label set. Case block 1. Return false. Case blow. CK. Case clause assault. Default clause. Case clause assault. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set as true, return true. 2. If contains duplicate labels of default clause with argument label set as true, return true. 3. If the second case clauses is not present, return false. 4. Return contains duplicate labels of the second case clauses with argument label set. Case clause 1. Let has duplicates be contains duplicate labels of case clauses with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of case clause with argument label set. Case clause, case expression, statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Default clause, default, statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Labeled statement, label identifier, label item. 1. Let label be the string value of label identifier. 2. If label set contains label, return true. 3. Let new label set be the list concatenation of label set and label. 4. Return contains duplicate labels of label item with argument new label set. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. 1. If contains duplicate labels of block with argument label set is true, return true. 2. If contains duplicate labels of catch with argument label set is true, return true. 3. Return contains duplicate labels of finally with argument label set. Catch parameter block. Return contains duplicate labels of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. 1. Let has duplicates b contains duplicate labels of module item list with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. Comma 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target. Takes argument label set. A list of strings and returns a boolean. It is defined piecewise over the follow. Productions. Statement. Variable statement. Empty statement. Expression statement. Continue statement. Return statement. Throw statement. Debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list. Statement list item. 1. Let has undefined labels b contains undefined break target of statement list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of statement list item with argument label set. If statement. If expression statement else statement. 1. Let has undefined labels b contains undefined break target to the first statement with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target to the second statement with argument label set. If statement. If expression statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression not. Expression not. Expression not statement. 4. Variable declaration list. Expression not. Expression not statement. 4. Lexical declaration. Expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. 4. Left hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5. Break statement. Break. 1. Return false. ECMA International 2024 113. Break statement. Break label identifier. 1. If label set does not contain the string value of label identifier, return true. 2. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assault. Default clause. Case clause assault. If the first case clause is present, then if contains undefined break target to the first case clauses with argument label set is true, return true. 2. If contains undefined break target of default clause with argument label set is true, return true. 3. If the second case clauses is not present, return false. 4. Return contains undefined break target to the second case clauses with argument label set. Case clauses. Case clauses. Case clause. 1. Let has undefined labels b contains undefined break target of case clauses with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label.
I just want to like print these out or whatever, just to see what's even in the list or whatever. Making a triangle is very boring. So like just printf, I guess. It's some macros, whatever. So now I'll use them. Is into here? I think so. Speaking console. Keyboard. JavaScript. Check for this entry. In the true case, I'll put the print the comma. So it's a more likely case, whatever. In the less likely case, we'll take the else, or we'll set the boolean to false. You can also check the loop count, but I don't want to figure out, I don't care. I'm just doing this. So, I don't know. Let's put this shit out. I can actually see use a turn maybe. Turn, no, I can't. This has a colon behind the scenes. So it won't fit in the turner segment. So I'm gonna print, then we're gonna load. So I have some idea of what's going on. When we get to the next page of the chapter, whatever, make a mother loving triangle. Alright, luckily the tutorial doesn't look too long. Just like a couple more pages. I need to get done. Or so I'd assume. Why didn't I just zoom out? I should just zoomed up. Anyways, I think extensions from whatever this is what's being put here. This one here, that happens to be this thing. Here. Why is this being called twice? So it calls it once to get the length. JavaScript calls it available extensions. It already knows the length. Because it's stated. So that's kind of, that makes sense. And then it calls them for real to actually get the extensions. They're being assigned to this, I guess. Which means this holds extensions. This is looping through them. It's looking for required extensions. This is where 0. This is global. Oh, it's looking for this. Swap chain extensions name. I see what the other extensions are. Using chatbot again. I need to stop, but it's addicting. Alright, so since it's only looking for one, what's the point in making a for loop when there's only one to iterate? What is even happening here? Constant chart pointer. Let's iterate. This size of the pointer, not the struct itself. Is doing that divided by. Oh, that's I've never done the size of an array with a 0. Is that valid? Well, I guess we can get the size of anything. I don't know what's going on here. This is funky. Funky monkey. I don't want to say what I think it is, because some chatbot might say, you're right. I want to see what chatbot says. So if I tell chatbot, I think the size of this is the size of the total array. This one. If I tell chatbot, I think the second one is the size of a pointer. Or is it going to be the size of the string that's held, because it is constant, but it's not technically actually constant. I don't know, whatever. It's really funky. I think this would be like considered code smell. Like code smell means like has a bad stink to it, but maybe it's not. I would never do that. This is like really funky. Asking chatbot anything is just as like solid as assuming. So that kind of sucks. Assuming chatbot's right in its result, it's the answer. I don't know, it's still assumption. Like, what does chatbot actually know? Other than how to like fucking lie. Alright, so the swap chain thing here, whatever. Break down the common use extension names. Not guaranteed on all platforms. Let's check using blah blah blah. Feature surface. I should be checking for that because I think I'm making that kind of surface. So I should have to be checking for that. But it doesn't do that. Chatbot just checks for swap chain. Oh, you can check for the platform. Dealer, Explorer, Wayland, Android. Man, Wayland really tries hard. Fucking try hard. Fucking Wayland. Alright, so this is 8. The size of a point or whatever. 8 bytes. So it's the size of the entire array. It's 24 exclusively of them. And if it was, forever. So it's not the length of the strings themselves. So doing size of 0, it returns 8. Why the fuck would chatbot waste time? Gives you the number of elements in an array, and it's safe, idiomatic. That's why. I think it's idiomatic, but I think it like idiomatic way. What is wrong with Linux? I'll click something and I can't click somewhere else because it gets stuck. It's not doing enough. Okay, so like hard coding it is more idiomatic than like getting length. This is ridiculous. It's getting length and there's only one thing in there. It's so stupid. This is really boring. It's gonna get basically what's inside this list. It's not exciting at all. Just gonna print one fucking thing. For one thing. Be great. So I'll just do it anyways. Print out one item in the list that's collected and request it. Alright, so this loops the available extensions by name. And then it breaks. I'm going to find some match to what's in this list. So print the number 2. And this number of things on the list that are retained windows to get such properties. It's PS, not print number. So I'm going to take this and then move it out of the loop to a separate loop. Because right now it's going to break on the first find. Which is not what I want. Because I want to like find everything in the list if there's more than one. So I have it print out what's in the list and I'll know what I need to check for possibly, or what I should check for. Because I doubt there's only one extension in the list when it does cool extensions. Guess I'll find out. Super exciting. So I'm gonna put this here. Actually remove this. And I'll just like, I'm gonna put, I'll undo whatever. I shouldn't mix debug stuff with the actual code. Because I'll forget, I'll have to like figure out later. And separate the debug stuff. loop through and print this shit. First undo. Make sure there's like no debug stuff below. Right here. And build makefile. Array. Boop-de-doo. I don't need this one. Now it should run. Nope. One 0. One down here. Oh, that's not a string. Damn, that's a lot of numbers. How are there 235 things in the extension list? Holy fuck. Did I like mess up my debug function? I'm just checking for one extension. Like what even? Oh man. What's wrong with my debug function? It's so laggy, it's not even clicking. Damn it. Oh no, it's Sublime. Please buy it. There we go. That's why. it's PT for print text. PS for print string, but I meant S for signed number. I should probably rename my print macros. I'm probably gonna make the mistake over and over and over. Well, this is a whole lot of things then. Extension list. Making a triangle has never been so exciting. It's not very exciting. So there's 235 things inside of the VK Anywhere device extension properties for the NVIDIA, whatever the fuck it is, TI thing. Quite a few. I'm just checking for one. Oh, my allergies are killing me. Separate these all with the space. I need a new line. Let's put a new line before the comma. Place all. Are there actually 235? I think the strings are just plain text. If a string had a comma inside of it, which I doubt, but if it did, it would make more than 235. Because I did find a place, so I'm gonna check to make sure it's 235. I really doubt a string had just a comma though. Strings in the list for extensions, whatever the fuck it is. Why does it say Google? What? What the hell does Google have to do? Google user type. Is that for the fucking web GPU shit? That's so stupid. Why didn't chatbot say that? Chatbot's like, oh yeah, here's what's in that list. You could have swappable chain extension. You could have debug utils, VHR surface, and missed out on all the juicy stuff, like fucking Google extension, whatever it even means. So I said, why is this on the list? What does it mean the GPU is capable of? Showing up in relation to VK Google user type, showing up in relation to, not relation, showing up in whatever the fucking list it is. The VK memory device extension properties. This is what I mean by the video card is fucking shit. The video card's like, oh, the video card, it only renders video. Yeah, chatbot.
How does the GPU not handle that all on its own, entirely separate from the CPU? CPU seems calling graphics when it relies on the graphics to process the graphics to process right or not. How does the GPU not handle that all on its own, entirely separate from the CPU? It seems misleading to call it a graphics processing unit when it relies on the CPU to feed it the graphics to process. The GPU should do more on it and right or not.
Text-to-speech has some bugs. That's really annoying. So I said, like, why can't the CPU be autonomous as you'd expect it to be from the CPU? And it says whatever here.
In theory, a fully autonomous GPU would be one that decides what to render, figures out how to render it. Thinking face. So why is today's GPU not fully autonomous in modern systems, even in 2025? The GPU still the GPU's role takes those instructions and executes them massively in parallel. Bricks. Why can't the GPU just do it all? Architectural specialization. GPUs are very efficient at parallel workloads, but not general purpose control logic.
So it's like, blah 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 blah, GPU just does GPU stuff and shit. But then on the fucking GPU, it's like, what does it support? It supports, what the fuck? Is Google user type. This is more than just rendering shit to the fucking screen. Is that Google again? I don't know. The GPU does more than just to render shit. The GPU should be fucking autonomous from the goddamn CPU. And then like the GPU could actually get real performance, because right now it's like tied to the fucking CPU having to like feed information to it. The video card company should fucking release the instruction set, architecture, and let you like access the damn video card instead of have to like access it through fucking structs and send it data, because you can't just like directly write to the fucking CPU on it. Because for it to have all this, it clearly has a CPU, it has memory, it's running some sort of operating system on the GPU. It's just stupid. So I'm saying, why is this in the list? What does it mean? What does it mean the GPU is capable of in relation to this type showing up in the enumeration device extension properties? It means a broken physical device, support for VK user type device extension. It's a non-standard, vendor-specific, published by Google, not part of Vulkan. To enable support for SPIR-V extension within shader modules. So like, so what? Even though it supports SPIR-V, Google wants to know that it's like a Google certified device, even though it can support SPIR-V separate from the Google. Wow, that's bullshit. That's called, you buy the newer card, you get features that the old ones also support, but they don't support because the developer has no access to the video card. You just access the video card via these stupid ass structs and this stupid fucking construct. It's all fucking controlled because it's Monopoly. You can just make up names to support certain companies but not others. But not others. It's freaking stupid. So instead of checking for KHR float 16 for whatever the fuck SPIR-V is, instead of just checking for these, user-defined type metadata for reflection debugging. Reflection is only debugging. I don't care. It doesn't matter. Like everyone knows that's what the GPU does. But it's just when it's like really obvious, it's like, wow, it's actually what's going on. Alright, so is that how the GPU works? Oh, here's SPIR-V 1.4. But chatbot's like, here's KHR. Are these even? SPIR-V. What does SPV stands for? I don't know why it doesn't say the actual SPIR-V in there. So I guess the GPU has memory on it, and they save a list of functions that you can call, and that's what your GPU supports. You could probably hack a GPU to make it support things that's not supposed to. GPU seems like a scam. No wonder they make so much money. So I guess it implies it enables the use of specific SPIR-V extensions. So maybe it's not a scam, because technically it does enable something related to Google, whatever the fuck it is. So it is a real thing, but this just seems very funky. Now it's all set up. Alright, so I'm gonna check for one thing right now. That's good enough. I'll just assume the rest of it works. Let's turn this off. And there's no point having this really. Let's check for 0. Because the counter's right here. So when j is equals 0 or does not equal 0, then print the comma. So I'll just get rid of this break then. In case there happens to be more that I need later. I actually need a count. Found count. Let's make a branch, it doesn't matter. Oh, I know it does need to break from the inner loop. Because once it finds the match, it's a loop too, yeah. This is a dumb way to loop. It should loop. The larger loop is the outer loop, or it should be. Not really though. I don't think it matters. Is a better loop through if there's 2 in here. Or 3 things in here. It's a better loop, possibly through 237 things. This whole thing is a better loop through 237 3 times. If it happens to be at the end, because these are at the end. So we do at least 235, 36 loops to find these 2. So we could do like 235 loops. To find this, then to find this. So it's a lot of loops. If I loop through these and compare them to these, I loop through this on the outer loop, and I do 1 loop of 235, and then 3 mini loops. So that should save freaking looping up, loop count, iterations, whatever. I'll see if Java agrees. Then I gotta make the triangle and stop. Getting distracted. You could also do 2 things per iteration or start from. I'm not gonna optimize this, never mind. Like both ends at the same time. That'd probably be the best. Like a candle at both ends. Fire. Let's flip the loops around then. Get back to make the triangle. So, loop, loop, I don't need the bool. I can actually count down to 0. Alright, so J is the extension count. I is the requirement. So leave that, I don't care. String compare, required extensions, available, extension name. I'm going to set this actually to the length of how many to match, which is no length, so I'll do this. The number how many are on the list. Cost match length. I'll just lazily get the length like this. That actually kind of works. Is it lazy? Yes. But, whatever. This is overall length, whatever. Of the things inside of the things defined. Like the required extensions, whatever. So I'll put this inside of here. Just to keep it, so I don't have to like repeat it. Because if I paste or change something, now it's like the same in both places. I don't think it's possible to have a chart pointer to an empty list. So there needs to always be something in it. Even if it's not, if it was possible, and the length is 0. If it enters and does the loop and doesn't find any matches, then I don't know. If it enters, if there's nothing to find, it'll be 0. So you can check the length here on return. And compare if it's equal to 0. Return true or false based on if found everything list. So if this is equal to no, actually 0 would mean that it was successful. Alright, so do like, if it's equals 0, I'll just check the value, whatever. Ternary, so then, if it's 0, everything was found and it's true. If it's not 0, I'll just equal 0. So if it's equals 0, true, otherwise false. So if it didn't find them all, it's not going to be 0. Because I'm going to set it now to the length to find and decrement it each time. So now it doesn't need the break. Yes, it does. So I'll do does not equal 0, then continue. So now I'll loop all the extensions, then check each extension, meaning these, against this list here to find the required extensions. Whenever it finds a required one, if it does, it'll decrement the found count. The number to find in advance is known. This is the wrong value because it's this number extension count, because it calls it the first time here to get the extension count. So it knows this is the right number. Okay, so it knows how many to find because it's the length of how many to find here from this value. It knows how many to look through because of this value. So look through the ones to look through, and then look through all the ones to find. When it finds a match, it'll compare here. If n equals 0, they didn't find it. When it did find it, it'll be 0. So when it hasn't found it, it'll continue, which means it'll just keep looping. When it does find it, it won't continue, it'll fall through. Decrement the count of how many to find of the found count. Break, and then it'll go on to the next one in the extension count of how many to go through on the card. So I don't think it's possible for this to be 0. Because the size of an array, I'm pretty sure an array needs to always have one thing in it. But if it ever did happen to be 0, I'll just account for it. So put like, if blah 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 equals 0. false. Because I don't want to like follow through. Won't do loop, because it won't do loop. It would turn true, because I'm checking for 0. I don't want to like play funky games with setting it to -1. I'll just do that. Alright, so if that ever happens to be 0 in the number of things to find, I'll set the found count to -1. Let's make a separate if right here. No, inline it. So check the match length. Minus match length does not equal 0. I'll just do match length. Alright, so now it's going to be match length minus -1 or 0. Yeah, no, this has code smell. I'll just do it more normally. I can't focus. I gotta make the triangle. And try to focus. So not equal 0. Let's set to match length, otherwise I'll make it -1. Because this will never be -1. That way, if it's -1, because the match length is 0, this will be false, because I'm checking for 0. And then it won't even enter this loop because it'll say j equals 0, j does not equal 0. Well, we'll enter this loop. But when it gets to here, it won't enter this loop because I will be equal 0. But this will be -1, which will mean that it's going to loop infinitely. Yeah, I'm not going to do this. It's not worth being clever. Alright, so if match count, match length is 0, is it possible for the extensions to be 0? That won't be a problem. You know what? I'm just gonna get this done. I can't talk as I'm doing something. It makes it way more complicated. There we go, it's working. this in. If it's equal to 0, return true, because it means I found them all. Else, fall through and return false. Alright, I'm leaving it like this. That's done. What am I missing? Damn it, am I missing a freaking brace? What's it complaining about? Oh, it's missing one of these. Alright, the debug thing is off. Forgot this. I'm not gonna rewrite anything else unless I have to. If I do rewrite it, I'm not gonna like explain it as I go, because I'm just gonna keep going in circles. I print here just to make sure it enters. I like print foobar. I put like Google Google. And then run it. Something's missing. Huh. has 2 indices and blah blah, it has failed. Wait, why did it fail? It didn't even print foobar. Alright, printed foobar. What? Oh, I meant... Speed does not equal 0. This is speed equals 0. There we go. Now it runs. Okay, now why the hell can't I put 2 things in here? Are those other things not defined? This doesn't exist. This doesn't exist. Why? These 2 exist. Okay, what's the point in making a fucking loop? Isn't there a way to like... check the compile environment? Because it's not present, because this isn't Windows 32. Why the fuck do I gotta make a fucking loop to check for the names? Because I can't even define it to check for it if it's not the system. And do I just make it a fucking string then? Like that? All this stuff is so dumb. How does it not support any of these? Wait, what? What is this then? It doesn't even show up in the fucking list. Why can't anything just make sense right off the fucking bat? Why does everything have to be so stupid? Or at least it says it failed because it didn't find them all. So that's working. I gotta print this and then I'm done trying to like debug shit. Fucking dumbass shit. Everything is so dumb. It takes so much fucking work to get the stupidest shit. So annoying. Common sense says there should be a way to make a file to put these fucking keywords in there, and if it doesn't support it, have it not run. What I gotta make also loop-de-loop to fucking check a fucking string. It's dumb as fuck. Fuck's sake. And why is this not equal to what its name is? So this is what the name is, and this is what it actually is. Why? It's just annoying as hell. It didn't copy. So this is the define, but this is the value. Now this value should exist in a list. And it does, it's right here. This is ridiculously stupid. What do I know though? What do I know? Maybe some people enjoy making strings, making loops, maybe people enjoy the process a little bit more than they should enjoy making a product, or the people that make products for people to make products from enjoy. This is just stupid as hell. I'm gonna get some more water and then I'm gonna undo. The loop that I made works, so I'm gonna leave it. If I did actually add more things to the list, I can add them now. I'm gonna get back to making a triangle. Luckily, this tutorial is very short, so hopefully the rest will be quick. I'm gonna try to like rush through the rest of the tutorial and not question every single thing because it take way too fucking long. I'll be right back.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Let declarations 3 be var scope. Declarations of finally. 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch parameter, block. Return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list, module item list, module item 1. Let declarations 1 be var scope declarations of module item list 2. Let declarations 2 be var scope declarations of module item 3. Return the list concatenation of declarations 1 and declarations 2, module item, import declaration 1. Return a new empty list, module item, export declaration 1. If export declaration is export variable statement, return var scope declarations of variable statement 2. Return a new empty list. ECMA International 2024 107, 2.8 static semantics. Top-level lexically declared names. The syntax-directed operation top-level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list, statement list, statement list item 1. Let names 1 be top-level lexically declared names of statement list 2. Let names 2 be top-level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item, statement 1. Return a new empty list. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. Takes no arguments and returns a list of parse n odes. It is defined piecewise over the following productions. Statement list, statement list, statement list item 1. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list 2. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item, statement 1. Return a new empty list. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top-level var declared names. The syntax-directed operation top-level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list, statement list, statement list item 1. Let names 1 be top-level var declared names of statement list 2. Let names 2 be top-level var declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item, statement, if statement is statement, labeled statement, return top level var declared names of statement, return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return the top level var declared names of labeled item, statement, if statement is statement, labeled statement, return top level var declared names of statement, return var declared names of statement, labeled item. Function declaration, return bound names of function declaration, 2.11 static semantics, top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list item 1. Let declarations 1 be top level var scope declarations of statement list 2. Let declarations 2 be top level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2, statement list item, statement, if statement is statement, labeled statement, return top level var scope declarations of statement, return var scope declarations of statement, statement list item, declaration, if declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration, be return declaration, return a new empty list, labeled statement, label identifier, labeled item, return T, he top level var scope declarations of labeled item, statement, if statement is statement, labeled statement, return top level var scope declarations of statement 2, return var scope declarations of statement, labeled item, function declaration 1. Return function declaration, ECMA International 2024 109.3 labels, 3.1 static semantics, contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set 2. If has duplicates is true, return true 3. Return contains duplicate labels of statement list item with argument label set if statement, if, expression statement else statement 1. Let has duplicate be contains duplicate labels of the first statement with argument label set 2. If has duplicate is true, return true 3. Return contains duplicate labels of the second statement with argument label set if statement, if, expression statement, return contains duplicate labels of statement with argument label set do while statement, do statement while, expression, return contains duplicate labels of statement with argument label set while statement, while, expression statement, return contains duplicate labels of statement with argument label set for statement 4, expression statement 4, var variable declaration list, expression statement 4, lexical declaration expression statement, return contains duplicate labels of statement with argument label set, 10, ECMA International 2024, for in of statement, 4, left-hand side expression in expression statement, 4, var for binding in expression statement, 4, for declaration in expression statement, 4, left-hand side expression of assignment expression statement, 4, var for binding of assignment expression statement, 4, for declaration of assignment expression statement, for await, left-hand side expression of assignment expression statement for await, var for binding of assignment expression statement, for await, for declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement, with expression statement, return contains duplicate labels of statement with argument label set, switch statement, switch, expression, case block, return contains duplicate labels of case block with argument label set, case block, 1. Return false, case blow, CK, case clause assopt, default clause case clause assopt. If the first case clauses is present, then, if contains duplicate labels of the first case clauses with argument label set is true, return true, 2. If contains duplicate labels of default clause with argument label set is true, return true, 3. If the second case clauses is not present, return false, 4. Return contains duplicate labels of the second case clauses with argument label set, case clause, 1. Let has duplicates be contains duplicate labels of case clauses with argument label set, 2. If has duplicates is true, return true, 3. Return contains duplicate labels of case clause with argument label set, case clause, case expression, statement list opt, 1. If the statement list is present, return contains duplicate labels of statement list with argument label set, 2. Return false, default clause, default, statement list opt, 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false, labeled statement, label identifier, labeled item. 1. Let label be the string value of label identifier. 2. If label set contains label, return true. 3. Let new label set be the list concatenation of label set and label. 4. Return contains duplicate labels of labeled item with argument new label set. ECMA International 2024-111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. 1. If contains duplicate labels of block with argument label set is true, return true. 2. If contains duplicate labels of catch with argument label set is true, return true. 3. Return contains duplicate labels of finally with argument label set. Catch, catch, catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list, empty, 1. Return false, class static block statement list, empty, 1. Return false, module item list, module item list module item, 1. Let has duplicates be contains duplicate labels of module item list with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of module item with argument label set. Module item, import declaration, export declaration, return false, 3.2 static semantics, contains undefined break target. The syntax directed operation contains undefined break target, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the follow. Productions, statement, variable statement, empty statement, expression statement, continue statement, return statement.
So I'm gonna like undo the stuff. Let's run it again. So prints foobar. Is this working? Just check if you can have anything. If it's possible to have a 0 size array. Or of course you can make a pointer to one that is null, I don't know, whatever. Wait, what? You can make an array that is your length. Alright, I guess you can. Well, I don't know, it counts for that then. It still catches it as an error. So put another thing in the list. Like, I don't know, foobar. There's no way foobar, it doesn't show up in the list. I don't see it in here. It'd be really funny if it did. There's no foobar. There's footprint. But foot is about as close as it'll get to being foobar. In the attribute extension supported, whatever it is for this video card. It's no foobar. So it should correctly fail when trying to find it. And the comment was after, not before the item list. After the item in the list. So found one of them, except since I didn't find both, it did fail, like correctly fail on purpose, so it's working. So later on, if I add extensions to this list, everything will work. And I don't have to worry about the length and stuff. Because that's like handled here with the size up and stuff. So this is where I left off, and everything works. So I'm gonna like, it works. I'm gonna try to focus and get through the rest of the tutorial. And make a freaking
Drawing a triangle.
I highlighted just this. Why did it read the whole thing?
Drawing a triangle.
I don't know. Make a triangle. Super exciting. So I got to here. I just finished debugging or like looking through what's in loop. It wasn't that exciting. But now I know what it's actually doing. It's looking through this stuff. So now, the next part of whatever fucking in the thing to draw a triangle. It's so boring. Drawing a triangle is so boring. Did I skip stuff? No, that's the whole thing. Alright, so now I'm on validation layers. Is that all it takes? Like 4 or 5 steps? I'm gonna try to focus, get done now, or whatever. Make a model of a triangle. Super fun stuff, but not really fun, really boring.
validation layers. What are validation layers? Using validation layers, message callback, debugging instance creation and destruction, testing, configuration. What are validation layers? The Vulkan API is designed around the idea of minimal driver overhead, and one of the manifestations of that goal is that there is very limited error checking in the API by default. Even mistakes as simple as setting enumerations to incorrect values or passing null pointers to required parameters are generally not explicitly handled and will simply result in crashes or undefined behavior. Because Vulkan requires you to be very explicit about everything you're doing, it's easy to make many small mistakes, like using a new GPU feature and forgetting to request it at logical device creation time. As. However, that doesn't mean that these checks can't be added to the API. Vulkan introduces an elegant system for this known as validation layers. Validation layers are optional components that hook into Vulkan function calls to apply additional operations. Common operations in validation layers are checking the values of parameters against the specification to detect misuse, tracking creation and destruction of objects to find resource leaks, checking thread safety by tracking the threads that calls originate from, logging every call and its parameters to the standard output, tracing Vulkan calls for profiling and replaying. Here's an example of what the implementation of a function in a diagnostics validation layer could look like. These validation layers can be freely stacked to include all the debugging functionality that you're interested in. You can simply enable validation layers for debug builds and completely disable them for release builds, which gives you the best of both worlds. Q families it has been briefly touched upon before that almost every operation in Vulkan, anything from drawing to uploading textures, requires commands to be submitted to a queue. There are different types of queues that originate from different queue families, and each family of queues allows only a subset of commands. For example, there could be a queue family that only allows processing of compute commands, or one that only allows memory transfer related commands. We need to check which queue families are supported by the device and which one of these supports the commands that we want to use. For that purpose, we'll add a new function, find queue families, that looks for all the queue families we need. But what if a queue family is not available? We could throw an exception in find queue families, but this function is not really the right place to make decisions about device suitability. For example, we may prefer devices with a dedicated transfer queue family, but not require it. Therefore, we need some way of indicating whether a particular queue family was found. It's not really possible to use a magic value to indicate the non-existence of a queue family, since any value of int32t could in theory be a valid queue family index including 0. Luckily, C++17 introduced a data structure to distinguish between the case of a value existing or not.
I hate stupidity. This is so stupid.
Luckily, C++17 introduced a data structure to distinguish between the case of a value existing or not.
If something exists or not, a separate value should be used to like specify the existence of something. You shouldn't use a value, a sentinel value, to specify if it's existent or not. It's just like, no, it's the laziest fucking thing. And what the fuck is this?
Luckily, C++17 introduced a data structure to distinguish between the case of a value existing or not.
Are people too dumb to understand? What does it mean, luckily? It's just so stupid. Why does C++ need to introduce a data structure that the whole point of writing code is to fucking write code? Why do you need C++ to do it for you? Fucking holy fuck. It's fucktardery, for fuck's sake. So fucking dumb. I gotta focus, not talk. I gotta get something done. I'm gonna focus. So stupid though. So dumb.
STD. Optional is a wrapper that contains no value until you assign something to it. At any point you can query if it contains a value or not by calling its asValue member function. That means that we can change the logic too. Introduction. After selecting a physical device to use, we need to set up a logical device to interface with it. The logical device creation process is similar to the instance creation process and describes the features we want to use. We also need to specify which queues to create now that we've queried which queue families are available. You can even create multiple logical devices from the same physical device if you have varying requirements. Start by adding a new class member to store the logical device handle in. VK device. Next, add a create logical device function that is called from init vulkan void init vulkan. VK device. Next, add a create logical device function that is called from init vulkan void init vulkan. Create instance. VK device. Next, add a create logical device function that is called from init vulkan. Void init vulkan. Create instance. Set up debug messenger. Pick physical device. Create logical device.
Why can't shit just work? Like, what the fuck? Fucking Control Shift P. Just find the default package. Simple as fuck. So, Control Shift P. There we go. Then, you can let package resource viewer, open resource default. So, package resource viewer, package. What the fuck is resource viewer? There is no resource viewer. What the fuck? There's no fucking, what the fuck? Oh my god, this is so stupid. Is it view package file? There's no default setting. Wait, maybe this is it. Now this is in it. Can I close it? Dang it, I gotta do it again. I just want font. Where the fuck is this fucking file? For fuck's sake. Does it not exist? Alright, I think this is the default folder. So we get the file path. Why is everything so fucking stupid? Oh, I took the 9 in there. Dude. It told me that the home file is different than the root. Right? It said there was no default file folder. I need to make the goddamn triangle. Fucking crap. How does it not exist? What the fuck? I am so annoyed. This is bad so far. Packages default. There's no default. There's no fucking default folder. Where the fuck is the default folder? Do I have to save the file to make it exist? I'll fucking save the file, sure. Alright, so this is in a default, or in the default folder, which doesn't seem to fucking exist. Where? Oh, here. See, it says like default / save on focus forever. So I'm just gonna open this one. I'm gonna hit save and see if it makes a folder called default. So it says that's what the fucking... Copy file path. This thing's in the default folder, just like this one was, but there is no default folder. So I try to go to default folder. There's no default. There's nothing in here. It doesn't say default. So I hit save. And then how the fuck is it in that folder if it doesn't exist? What the fuck? This makes no sense. I don't get it. I just gotta make a triangle. Oh no, it's like... I'll make a folder called default, and then I'll put a file in it called font.py. change the file extension itself. Why can't anything just be simple, for fuck's sake? Holy fuck. Fuck is package resource variable? Oh my god. I have to install package. How the fuck? God damn it. I thought it was default. I think I have it installed. Open resource default. Package resource variable. There we go. Dang it. Open resource. Is there no font? .py? What? Everything is shit, for fuck's sake. Oh my god. Holy fuck. Oh yeah, that makes sense. Of course we call it zoom.py. Oh, that doesn't exist either. Thank you, Jetbot. Fucking piece of shit. Of course that's where zoom would be. Zoom.py of course would have zoom limits. For fuck's sake. Oh my god. Fucking shit. How dumb. I can't even unzip it. This is not a zip file. I'm gonna make the triangle. Whatever. Fucking holy fuck. Fuck everything, for fuck's sake. God damn it. Literally. Fucking idiots. God. Oh my god, everything's just a waste of time. Back to the fucking triangle shit. I want to do one simple thing. I just want to change. Set the max zoom and change it so it zooms at bigger intervals because it's too laggy. But no, it's really fucking complicated for me. It's not the same as Windows. There is no file. I don't know who the fuck the fucking file is, for fuck's sake. Oh, it's so stupid. What the fuck is this shit? Let's I'm gonna like skip ahead. I just don't give a fuck. I just wanna get it running. No, there's even more. It's in here. There's more shit to do. Oh my god. Oh, this is more than I thought it'd be. Man. I have to get some pop. Fuck everything. Eat your mom too.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope. Declarations of block. 2. Let declarations 2 be var scope. Declarations of catch. 3. Let declarations 3 be var scope. Declarations of finally. 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch. Catch parameter. Block. Return the var scope. Declarations of block. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the top level var scope. Declarations of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var scope. Declarations of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var scope. Declarations of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item 1. Let declarations 1 be var scope. Declarations of module item list. 2. Let declarations 2 be var scope. Declarations of module item. 3. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration 1. If export declaration is export variable statement, return var scope. Declarations of variable statement. 2. Return a new empty list. ECMA International 2024 107. 2.8 Static semantics. Top-level lexically declared names. The syntax-directed operation top-level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let names 1 be top-level lexically declared names of statement list. 2. Let names 2 be top-level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration. 2.9 Static semantics. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. Takes no arguments and returns a list of parse n odes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statements list. 2. Let declarations to be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statements list item. 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. 1. Let names 1 be top level var declared names of statement list. 2. Let names 2 be top level var declared names of statement list item. 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration, 2.11 static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. 1. Let declarations 1 be top level var scope declarations of statement list. 2. Let declarations 2 be top level var scope declarations of statement list item. 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return T. He top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics. Contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item, declaration, return false, statement list item. 1. Let has duplicates be contains duplicate labels of statement list with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of statement list item with argument label set. If statement, if, expression statement, else statement. 1. Let has duplicate be contains duplicate labels of the first statement with argument label set. 2. If has duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement. 4. Expression statement. 4. Var variable declaration list. Expression statement. 4. Lexical declaration expression Expression or statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement. With expression statement. Return contains duplicate labels of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains duplicate labels of case block with argument label set. Case block. 1. Return false. Case blow. CK. Case clause assopt. Default clause case clause assopt. If the first case clause is present, then
I highly doubt that this tutorial is complete. I bet that if I followed this tutorial from top to bottom, nothing's perfect. So I don't know why I'm going from top to bottom. I'm just gonna like skip around in the tutorial and get what I need from it and get shit running. Everything is shit. Even tutorials, they like miss stuff. Nothing's like, everything sucks basically. So I don't know why I'm like expecting this to like be any better. I'm just gonna skip through stuff and make a fucking triangle. It'll be a waste of time to read all these words with all these extra words inserted. I just want basic info. This is way too much. It's just stupid as fuck, annoying. I just want to get the fucking standard. I don't want to do this forever. This fucking sucks.
Windows surface creation. Start by adding a surface class member right below the debug callback vk surface k hr surface. Swap chain. Checking for swap chain support. Enabling device extensions. Querying details of swap chain support. Choosing the right settings for the swap chain surface format presentation mode swap extent. Creating the swap chain. Retrieving the swap chain images. Vulkan does not have the concept of a default frame buffer. Hence it requires an infrastructure that will own the buffers we will render to before we visualize them on the screen. This infrastructure is known as the swap chain and must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be presented to the screen. Our application will acquire such an image to draw to it, and then return it to the queue. How exactly the queue works and the conditions for presenting an image from the queue depend on how the swap chain is set up. But the general purpose of the swap chain is to synchronize the presentation of images with the refresh rate of the screen.
Okay, so for fuck's sake.
This
Oh, it's working.
chain and must be created explicitly in Vulkan.
Explicitly in Vulkan. What the fuck does that even mean? I'm so tired of the nonsense and giving a name to something, to like a terminology or concept. Like, I'm looking for malloc. Malloc, here we go. Actually here. Swap chain images. Malloc. Fucking malloc. This is a standard for the CPU to allocate memory in a C program. The swap, it's the size of a VK image times swap chain image count. So however many swap chain images is how big it has to be. VK image. How big is VK image? Or is this just a structure that holds it? It's not the image. Just here, so it's a pointer. Oh my god, my ass chatbot. For fuck's sake, I'm so tired of everything. Everything is shit. Everything is fucking shit. Everything is shit. What type is VK image? A big handle. Pointer VK image channel. Not the image itself, but address. So this one's the size of image VK image without the pointer. What type is VK image? It's structured. Oh my god, I don't care what the fuck it's called. It's blah 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 blah. Okay then. Then what is size of VK image? If it's a pointer, I swear to god. What? This is so dumb. This is a double pointer. Okay, so why the fuck? This is so dumb. Why make a malloc? Is anything a sign? It should be right here. I'll just print whatever the fuck this is. Okay, I guess technically then it is actually created in a Vulkan because it's like an opaque handle. You can't access it. It looked like it's just an image that you sent, which I think it might be, but it's a pointer to a handle, so I don't fucking care. But if you call malloc to make something and send it in, then it's like that's not very explicitly Vulkan-like because you're making a handle, so malloc. So, I guess that's just the handle that holds the handle of a handle, because calling a handle is based on context, whatever. Everything's whatever. Swap chain image count. So 2. That makes 16. So it's just a pointer array. This returns 2. Message about. Since it ends up being 2, does it mean it's double buffered? Or does it swap between 2 and it's not double buffered? And if it was double buffered, would that be 4? Because, or would that be 3? I don't know, whatever. Double buffering. I thought I don't know, double buffering would be more like double, but I guess the swap itself is technically double buffering. Even though it's not really double buffering, it's like viewing the one image as it flips the next one instead of stalling between. Double buffer would really be like 2 in the buffer before the next one. Because if you swap between 2, you only single buffered. So there's no such thing as single buffering. A double buffer isn't double buffering though. It's viewing one as it paints the other. Therefore, one's viewed, there's nothing doubled. Like, okay, wait, I think I got it. So I set a checkbot. So a double buffer views one as the other is painted, then it flips. It does not hold 2 as it's painted and flips, but holds 1 as painted and flips. It's not 2 being saved, then viewed. It's not 2 being saved, 2 then viewed. It's still double buffering, though there's nothing extra buffered since it's being painted. I guess technically though, it is double buffering because you view one of them as the second one is being buffered in the process of being viewed, and then you flip to it, and then you view it. So I guess technically, if you think of buffering as like the state of painting, no, but then I mean like, it's buffering 2 things. You know what, I don't care. It's not a buffer though. If one of them is being viewed, it's not buffered because it's being viewed. The front buffer is displayed on the screen, therefore it shouldn't be called a buffer. Everything's a buffer then. Every fucking thing that exists in memory is technically a buffer. If the front buffer is displayed on the screen, how is it a buffer? It is not in the process of having data applied to it. So how is it being buffered if it's being displayed? there's nothing applied to it. So how can it be considered part of a double buffer? Nothing is being buffered twice the amount. Only the next flip is being prepared. There's no double of what is buffered to display. So triple buffering should be like double buffering. Only a single buffer is prepared each flip, not two. Though physically there are two to flip between. Excellent question, you're absolutely right to challenge the terminology. Why is the front buffer still called a buffer? Even though nothing's being read to it, just displayed, it's still a buffer because it holds memory. Wow. The display system reads it in real time. It must be held in undisturbed. You cannot write to it safely. So the front buffer is stored, blah blah blah. Not actively being buffered into your write, it's not receiving writes. Double buffering doesn't mean each frame is stored twice. I know what it means. So your point, nothing's being buffered twice the amount. You're correct, you only buffer one image per frame. Only a single buffer is prepared per flip. Only one buffer is run a targeted time. Why this terminology persists? Single buffering meant you render into the same memory. That's shown, causing tearing and flickering. Double buffering introduced a second buffer, you render off screen, then flip. But it's not. The name's stuck, even though technically only one buffer is being buffered. So it's called double buffering to make it sound better than single buffering, even though it's not really double buffering. It's just using two buffers. Single buffering is the only terminology that makes sense because it's one buffer. It's also being output as it's being written to or between. This is so boring.
Checking for swap chain support. Not all graphics cards are capable of presenting images directly to a screen for various reasons. For example, because they are designed for servers and don't have any display outputs. Secondly, since image presentation is heavily tied into the Windows system and the surfaces associated with Windows, it is not actually part of the Vulkan core. You have to enable the VKK HR swap chain device extension after querying for its support. For that purpose, we'll first extend the is device suitable function to check if this extension is supported. We've previously seen how to list the extensions that are supported by a VK physical device, so doing that should be fairly straightforward. Note that the Vulkan header file provides a nice macro VKK HR swap chain extension. Our method is defined as VKK HR swap chain. The advantage of using this macro is that the compiler will catch misspellings.
Didn't I already talk about this before? Okay, who knows? I'll do this one.
Introduction. Over the course of the next few chapters, we'll be setting up a graphics pipeline that is configured to draw our first triangle. The graphics pipeline is the sequence of operations that take the vertices and textures of your meshes all the way to the pixels in the render targets. A simplified overview is displayed below.
I got some stuck in my contact lens. Damn it.
Function declaration 1. Return a new empty list. Try statement. Try block catch. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of finally. 3. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. 1. Let declarations 1 be var scope declarations of block. 2. Let declarations 2 be var scope declarations of catch. 3. Let declarations 3 be var scope declarations of finally. 4. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch, catch, catch parameter, block. Return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module empty. Return a new empty list. Module item list. Module item list. Module item 1. Let declarations 1 be var scope declarations of module item list. 2. Let declarations 2 be var scope declarations of module item. 3. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration 1. If export declaration is export variable statement, return var scope declarations of variable statement. 2. Return a new empty list. ECMA International 2024 107, 2.8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let names 1 be top level lexically declared names of statement list. 2. Let names 2 be top level lexically declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. Takes no arguments and returns a list of parse n odes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. 2. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let names 1 be top level var declared names of statement list. 2. Let names 2 be top level var declared names of statement list item 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration, 2.11 static semantics. Top level var scope declarations. The syntax directed operation top level. Introduction over the course of the next few. Introduction over The input assembler collects the raw vertex data from the buffers you specify and may also use an index buffer to repeat certain elements without having to duplicate the vertex data itself. The vertex shader is run for every vertex and generally applies transformations to turn vertex positions from model space to screen space. It also passes per vertex data down the pipeline. The tessellation shaders allow you to subdivide geometry based on certain rules to increase the mesh quality. This is often used to make surfaces like brick walls and staircases look less flat when they are nearby. The geometry shader is run on every primitive, triangle, line, point, and can discard it or output more primitives than came in. This is similar to the tessellation shader, but much more flexible. However, it is not used much in today's applications because the performance is not that good on most graphics cards except for Intel's integrated GPUs. The rasterization stage discretizes the primitives into fragments. These are the pixel elements that they fill on the frame buffer. Any fragments that fall outside the screen are discarded and the attributes outputted by the vertex shader are interpolated across the fragments, as shown in the figure. Usually the fragments that are behind other primitive fragments are also discarded here because of depth testing. The fragment shader is invoked for every fragment that survives and determines which frame buffer, S, the fragments are written to and with which color and depth values. It can do this using the interpolated data from the vertex shader, which can include things like texture coordinates and normals for lighting. The color blending stage applies operations to mix different fragments that map to the same pixel in the frame buffer. Fragments can simply overwrite each other, add up, or be mixed based upon transparency stages with a green color known as fixed function stages. These stages allow you to tweak their operations using parameters, but the way they work is predefined. Stages with an orange color, on the other hand, are programmable, which means that you can upload your own code to the graphics card to apply exactly the operations you want. This allows you to use fragment shaders, for example, to implement anything from texturing and lighting to ray traces. These programs run on many GPU cores simultaneously to process many objects, like vertices and fragments in parallel. If you've used older APIs like OpenGL and Direct3D before, then you'll be used to being able to change any pipeline settings at will with calls like glblend-func and omsetBlendState. The graphics pipeline in Vulkan is almost completely immutable, so you must recreate the pipeline from scratch if you want to change shaders, bind different frame buffers, or change the blend function. The disadvantage is that you'll have to create a number of pipelines that represent all of the different combinations of states you want to use in your rendering operations. Capital H. However, because all of the operations you'll be doing in the pipeline are known in advance, the driver can optimize for it much better. Some of the programmable stages are optional based on what you intend to do. For example, the tessellation and geometry stages can be disabled if you are just drawing simple geometry. If you are only interested in depth values, then you can disable the fragment shader stage, which is useful for shadow map generation. In the next chapter, we'll first create the two programmable stages required to put a triangle onto the screen: the vertex shader and fragment shader. The fixed function configuration, like blending mode, viewport, rasterization, will be set up in the chapter after that. The final part of setting up the graphics shader modules: vertex shader, fragment shader, per vertex colors, compiling the shaders, loading a shader, creating shader modules, shader stage creation. Unlike earlier APIs, shader code in Vulkan has to be specified in a bytecode format as opposed to human-readable syntax like GLSL and HLSL. This bytecode format is called SPIVI and is designed to be used with both Vulkan and OpenCL, both Cronus APIs. It is a format that can be used to write graphics and compute shaders. But we will focus on shaders used in Vulkan's graphics pipelines in this tutorial. The advantage of using a bytecode format is that the compilers written by GPU vendors to turn shader code into native code are significantly less complex. The past has shown that with human-readable syntax like GLSL, some GPU vendors were rather flexible with their interpretation of the standard. If you happen to write non-trivial shaders with a GPU from one of these vendors, then you'd risk other vendors' drivers rejecting your code due to syntax errors, or worse, your shader running differently because of compiler bugs. With a straightforward bytecode format like SPIVI, that will hopefully be avoided. However, that does not mean that we need to write this bytecode by hand. Cronus has released their own vendor-independent compiler that compiles GLSL to SPIVI. This compiler is designed to verify that your shader code is fully standards compliant and produces one SPIVy binary that you can ship with your program. You can also include this compiler as a library to produce SPIVy at runtime, but we won't be doing that in this tutorial. Although we can use this compiler directly via GLSlang validator eggs, we will be using GLSLC eggs by Google instead. The advantage of GLSLC is that it uses the same parameter format as well-known compilers like GCC and Clang and includes some extra functionality like includes. Both of them are already included in the Vulkan SDK, so you don't need to download anything extra.
Could this just work? Just work. Could it please just work?
Shading lab.
Oh, there it goes.
Syntax. Programs written in it have a main function that is invoked for every object. Instead of using parameters for input and return value as output, GLSL uses global variables to handle input and output. The language includes many features to aid in graphics programming, like built-in vector and matrix primitives. Functions for operations like cross products, matrix vector products and reflections around a vector are included. The vector type is called vec with a number indicating the amount of elements. For example, a 3D position would be stored in a vec3. It is possible to access single components through numbers like .x, but it's also possible to create a new vector from multiple components at the same time. For example, the expression vec3, 1.0, 2.0, 3.0 would result in vec2. The constructors of vectors can also take combinations of vector objects and scalar values. For example, a vec3 can be constructed with vec3, vec2, 1.0, 2.0, 3.0. As the previous chapter mentioned, we need to write a vertex shader and a fragment shader to get a triangle on the screen. The next two sections will cover the GLSL code of each of those, and after that I'll show you how to produce two SPIVy binaries and load them into the program. Vertex shader. The vertex shader processes each incoming vertex. It takes its attributes, like world position, color, normal and texture coordinates as input. The output is the final position in clip coordinates and the attributes that need to be passed onto the fragment shader, like color and texture coordinates. These values will then be interpolated over the fragments by the rasterizer to produce a smooth gradient. Now. Vertex shader. The vertex shader processes each incoming vertex. It takes its attributes, like world position, color, normal and texture coordinates as input. The output is the final position in clip coordinates and the attributes that need to be passed onto the fragment shader, like color and texture coordinates. These values will then be interpolated over the fragments by the rasterizer to produce a smooth gradient. A clip coordinate is a four-dimensional vector from the vertex shader that is subsequently turned into a normalized device coordinate by dividing the whole vector by its last component. These normalized device coordinates are homogeneous coordinates that map the Framber fit to a -1, 1 by -1, 1 coordinate system that looks like the following. You should already be familiar with these if you have dabbled in computer graphics before. If you have used OpenGL before, then you'll notice that the sign of the y coordinates is now flipped. This x coordinate now uses the same range as it does in direct 3D. From 0 to 1 for our first triangle, we won't be applying any transformations. We'll just specify the positions of the three vertices directly as normalized device coordinates to create the following shape. We can directly output normalized device coordinates by outputting them as clip coordinates from the vertex shader with the last component set to 1. That way the division to transform clip coordinates to normalized device coordinates will not change anything. Normally these coordinates would be stored in a vertex buffer, but creating a vertex buffer in Vulkan and filling it with data is not trivial. Therefore I've decided to postpone that until after we've had the satisfaction of seeing a triangle pop up on the screen. We're going to do something a little unorthodox in the meanwhile. Include the coordinates directly inside the vertex shader. The code looks like this. No, the 0.5 minus 0.5 minus 1. 1 can the value be larger than plus 1? Got it now. You're asking, can the coordinate values in a vec2, like 0.5 minus 0.5, etc., be larger than plus or minus 1.0 in a Vulkan shader? Tick. Yes, the values can be larger than plus or minus 1.0, but it depends on how you're using them and which coordinate space they're in. Sparkles. So what happens with values outside plus or minus 1.0? Let's say you do something like vec2 positions 3 equals vec2 0.0 minus 3.0 vec2 5.0 vec2 minus 10.0 4.0. If you use these in a vertex shader like GLS, I'll copy it to void main. GL position equals vec4 positions GL vertex int x 0. Then these values go directly into GL position, meaning they are in clip space. Now, values outside 1.0 to plus 1.0 will be clipped. That is, not visible. Values outside W to plus W will be culled entirely, but they are still valid. The shader won't error out. Spanner, TL, DR. Yes, you can use values larger than plus or minus 1.0, but if they go into GL position, anything outside minus 1, 1, after division by W, will be clipped or not rendered. For model or world space math, you can use any size or scale you want.
What? What's the resolution if you can't use more than 1? Like, if you're using, like, floating point, you're limited to the floating point resolution remainder. Is it only 22 bits? No, it's not. It's like 22 bits for, like, the main, what is it called? What, it starts with N, whatever it is.
What's the whole number range? It ends up being limited to the floating point precision range. What this resolution is that, used to represent the remainder of a whole number in floating point. Great follow-up. You're now digging into the bit-level precision of floating point numbers, especially as it relates to representing whole numbers versus fractional remainders, which is key in graphics and shader math.
8 bits? How do you get 24 bits? that's so stupid.
There's an invisible leading bit. All normalized floats assume a leading one, so you effectively get 24 bits of precision.
Does a normalized float mean that you can have nan or whatever? You know, it doesn't matter. This just says 1 1. It says 6.25, whatever. Man, Tesla? I don't care about how the fuck you say it. Tesla, whatever the fuck it is. Just like set the bits. Right. That's it. $129. Okay, so that's 110. That is 6. 106. Power of 2. Move the decimal place. So now decimal place is move 2. So we got 1. 1001. 1001 is 9. One zero zero one. $25. 6.25. plus 2 is 127. 27 plus 2 is 129. I don't understand what the fuck. What even the actual fuck? That makes no sense. You know what? I don't care. This is like the worst way to describe anything. Holy fuck. So I guess precision whatever is 26 bits. 23. This isn't that small of a number. So for like a 4K resolution whatever, for depth, like 1920 by 108, that like there's enough to have like enough depth, length, width too, but then like when you get to 4K, the resolution like depth wise, I don't think it can match width and height. Because if you double, you know what, I don't know, whatever. It seems like there's not enough precision. By using only 0 to 1. The vertex, whatever. Or like there should be more precision in the vertexes other than just 0 to 1. I guess that's enough though, I don't know. And the GPU can only compute so much. It's at like 2.30 megahertz or something, gigahertz or something, I don't know. It's still in the CPU.
The main function is called for every fragment, just like the vertex shader main function is called for every vertex. Colors in GLS are 4 component vectors with the R, G, B, and alpha channels within the 0, 1 range. Unlike GL position in the vertex shader, there is no built-in variable to output a color for the current fragment. You have to specify your own output variable for each frame buffer where the layout, location equals 0, modifier specifies the index of the frame buffer. The color red is written to this outcolor variable that is linked to the first, and only, frame buffer at index 0. We have to make a couple of changes to both shaders to accomplish this. First off, we need to specify a distinct color for each of the 3 vertices. The vertex shader should now include an array with colors just like it does for positions. vec3 colors 3 equals vec3 vec3 1.0 0.0 0.0 vec3 0.0 1.0 0.0 vec3 0.0 0.0 1.0.
So that must be these super awesome, amazing files that Jetpack gave last time. Like shaders, SPV, whatever. I told Jetpack that I want to like invert a triangle, the colors, whatever. Because Jetpack couldn't do like the simple shit I was asking it to do. And it gave me this stuff. Well, this is like the compiled code. Why are there more of them? So this looks like this. That looks the same. And this other file looks like this. I'll just like rewrite this. Whatever they have on there. space needed there. All files look the same.
Fragment shader. The triangle that is formed by the positions from the vertex shader fills an area on the screen with fragments. The fragment shader is invoked on these fragments to produce a color and depth for the frame buffer or frame buffers. A simple fragment shader that outputs the color red for the entire triangle looks like this. The main function is called for every fragment, just like the vertex shader main function is called for every vertex. Colors in GLS are 4-component vectors with the R, G, B, and alpha channels within the 0, 1 range. Unlike GL position in the vertex shader, there is no built-in variable to output a color for the current fragment. You have to specify your own output variable for each frame buffer where the layout, location equals 0. Modifier specifies the index of the frame buffer. The color red is written to this outcolor variable that is linked to the first and only frame buffer at index 0.
So this isn't for like pixel manipulation. This is like applying effect across something that exists. Probably why it's called a shader, not a pixelator. A pixelator sounds cool. This is just lame. It's like an Instagram filter. So what this is like red, green, blue. This is alpha maybe. So this will make a red triangle. Possibly, who knows.
The vertex colors making the entire triangle red is not very interesting. Wouldn't something like the following look a lot nicer?
It would be red, okay, so it's red, green, blue. Then 1 for alpha.
We have to make a couple of changes to both shaders to accomplish this. First off, we need to specify a distinct color for each of the 3 vertices. The vertex shader should now include an array with colors just like it does for positions. Now we just need to pass these vertex colors to the fragment shader so it can output their interpolated values to the frame buffer. Add an output for color to the vertex shader and write to it in the main function. Compiling the shaders, create a directory called shaders in the root directory of your project and store the vertex shader in a file called shadervert and the fragment shader in a file called shaderfrag in that directory. GLSL shaders don't have an official extension, but these two are commonly used to distinguish them. The contents of shadervert should be.
think it's set up to compile it at runtime. So I'll just not compile it. Replace these. Maybe it'll just work. Or not. Way to create some that destroys them. Why does it destroy them after it sets them to the pipeline? Is it not needed anymore? I gotta figure out, I guess.
We'll now call this function from create graphics pipeline to load the bytecode of the two shaders.
With the pipeline. I just want to make a fucking triangle. It covers a whole bunch of shit unrelated to the fucking triangle. For God's sake. It should just cover shit related to the damn triangle. Don't call it. Don't call it fucking drawing a triangle if there's a bunch of non-triangle related stuff in it. For fuck's sake. Way too fucking wordy. I just don't care. Just give me the fucking info. I fucking hit save. I commented out the old ones. So why is it doing the old ones still? Alright, see if those back to what they were. Oh, come on. What the fuck? Nine, 2067. I thought the make file was bigger than this. This was the make file. Wait, what? What was the other file? Is it destroying itself? What file did it pull up then? Why is everything shit? Why is everything shit? Oh my god, this is stupid. So this is a real make file. I don't know what the fuck the other file was. It's not this file. It's supposed to be. I clicked open. Oh my god. Whatever. I hate chatbot. I fucking hate chatbot. Chatbot told me this would like generate the shit at runtime. Load shader module. Or create. I hate chatbot. It's so stupid. Oh my god, it's so dumb. Okay, it doesn't actually make these at runtime, it just loads them. Chatbot said that it would like generate them at runtime, which is completely misleading. So I gotta fucking compile these one by one then. Oh, everything's stupid as fuck.
3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Notes at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Notes at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return a top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item 1. Let declarations 1 be top level var scope declarations of statement list. 2. Let declarations 2 be top level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return a top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 static semantics, contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item, declaration, return false. Statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of statement list item with argument label set. If statement, if expression statement else statement 1. Let has duplicate be contains duplicate labels of the first statement with argument label set. 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while expression, return contains duplicate labels of statement with argument label set. While statement, while expression statement, return contains duplicate labels of statement with argument label set. For statement 4. Expression not statement 4. var variable declaration list expression not statement 4. Lexical declaration expression not statement, return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement 4. Left hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement 4. Left hand side expression of assignment expression statement 4. var for binding of assignment expression statement 4. For declaration of assignment expression statement for await. Left hand side expression of assignment expression statement for await. var for binding of assignment expression statement for await. For declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XP 3.5 with statement with expression statement, return contains duplicate labels of statement with argument label set. Switch statement, switch, expression, case block, return contains duplicate labels of case block with argument label set. Case block 1. Return false. Case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set is true, return true. 2. If contains duplicate labels of default clause with argument label set is true, return true. 3. If the second case clauses is not present, return false. 4. Return contains duplicate labels of the second case clauses with argument label set. Case clause 1. Let has duplicates be contains duplicate labels of case clauses with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of case clause with argument label set. Case clause, case expression, statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Default clause, default, statement list opt. 1. If the statement list is pre-sent, return contains duplicate labels of statement list with argument label set. 2. Return false. Labeled statement, label identifier, labeled item. 1. Let label be the string value of label identifier. 2. If label set contains label, return true. 3. Let new label set be the list concatenation of label set and label. 4. Return contains duplicate labels of labeled item with argument new label set. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. 1. If contains duplicate labels of block with argument label set is true, return true. 2. If contains duplicate labels of catch with argument label set is true, return true. 3. Return contains duplicate labels of finally with argument label set. Catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list, empty. 1. Return false. Class static block statement list, empty. 1. Return false. Module item list, module item list, module item. 1. Let has duplicates be contains duplicate labels of module item list with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of module item with argument label set. Module item, import declaration, export declaration, return false. 3.2 static semantics, contains undefined break target. The syntax directed operation contains undefined break target, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item, declaration, return false. Statement list item. 1. Let has undefined labels be contains undefined break target of statement list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement else statement. 1. Let has undefined labels be contains undefined break target to the first statement with argument label set. 2. If has undefined labels is true, return true. true. 3. Return contains undefined break target of the second statement with argument label set. If statement, if, expression statement. Return contains undefined break target of statement with arg. Humans label set. Do while statement, do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement, while. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression not, expression not, expression not statement. 4. Var variable declaration list. Expression not statement. 4. Lexical declaration expression not statement. Return contains undefined break target of statement with argument label set. For an of statement. 4. Left-hand side expression in expression statement. 4. Var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. Var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. Var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5. Break statement. Break. 1. Return false. ECMA International 2024 113. Break statement. Break label identifier. 1. If label set does not contain the string value of label identifier, return true. 2. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assault. Default clause. Case clause assault. If the first case clause is present, then if contains undefined break target of the first case clauses with argument label set is true, return true. 2. If contains undefined break target of default clause with argument label set is true, return true. 3. If the second case clauses is not present, return false. 4. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses. Case clause. 1. Let has undefined labels be contains undefined break target of case clauses with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false. Default clause. Default. Statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false. Labeled statement. Label identifier. Labeled item. 1. Let label be the string value of label identifier. 2. Let n. U label set be the list concatenation of label set and label. 3. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. 1. If contains undefined break target of block with argument label set is true, return true. 2. If contains undefined break target of catch with argument label set is true, return true. 3. Return contains undefined break target of finally with argument label set. Catch parameter, block. Return contains undefined break target of block with argument label set. Function statement list, empty. 1. Return false. Class static block statement list, empty. 1. Return false. Module item list, module item list, module item. 1. Let has undefined labels be contains undefined break target of module item list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of module item with argument label set. Module item, import declaration, export declaration, return false. Comma 3.3 static semantics, capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE. The syntax directed operation, capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block. Statement list item, declaration, return false, statement, block statement, return, capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE. A block statement with arguments iteration set and ECMA International 2024 115. Breakable statement, iteration statement. 1. Let new iteration set be the list concatenation of iteration set and label set. 2. Return, capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE. Of iteration statement with arguments new iteration set and statement list item. 1. Let has undefined labels be capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE. Of statement list with arguments iteration set and 2. If has undefined labels is true, return true. 3. Return, capital C.
I'm not gonna read this tutorial. Instead, I'm gonna like jump around, figure it out, cause I don't want to fucking read it. There's a bunch of shit in here. I don't give a fuck. I just want to get this running. So I'm gonna figure it out, whatever. Find some music, get it running. I hate tutorials, especially when it says drawing a triangle. There's a whole bunch of stuff unrelated to the triangle. I just want to make a triangle. That's all I want to do. I'm just gonna figure it out.
If statement, if expression statement, else statement, statement 1. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration second. If statement, if expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. Do while statement, do statement while. Expression, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. While statement, while. Expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. For statement 4. Expression statement 4. The variable declaration list. Expression statement 4. Lexical declaration expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. For in of statement 4. Left-hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement.
Alright, so that's what happened.
Expression.
That sounds like, where's the file? Apparently, I had to scroll up. But it opened the file like this, and I thought, where'd the file go? It was up here. I had to scroll up. I don't know, I just realized that. So it did open the file. But it wasn't open at the top of the file. So that makes sense, I guess.
D E F I N E D, capital CONTINUE, capital TARGE, of statement with arguments iteration second. Note this section is extended by an XB. 3.5 Continue statement. Continue. 1. Return false. 16 ECMA International 2024. Continue statement. Continue label identifier. 1. If iteration set does not contain the string value of label identifier, return true. 2. Return false with statement. With expression statement, return capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of statement with arguments iteration second. Switch statement. Switch. Expression. Case block. Return. Capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of case block with arguments iteration second. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of the first case clauses with arguments iteration second is true, return true. 2. If capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of default clause with arguments iteration second is true, return true. 3. If the second case clauses is not present, return false. 4. Return capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of the second case clauses with arguments iteration second. Case clauses. Case clauses. Case clause 1. Let has undefined labels be capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of case clauses with arguments iteration second. 2. If has undefined labels is true, return T. Ru. 3. Return capital CONTAINS, capital UNDEFINED, capital CONTINUE, capital TARGE, of case clause with arguments iteration second. Case clause. Case expression. Statement list opt. 1. If the statement list is present, return capital CONTAINS, O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration second. 2. Return false. Default clause. Default. Statement list opt. 1. If the statement list is present, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration second. 2. Return false. Labeled statement. Label identifier. Labeled item. 1. Let label be the string value of label identifier. 2. Let new label set be the list concatenation of label set and label. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of labeled item with arguments iteration set to new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of catch with arguments iteration second. ECMA International 2024 117. Try statement. Try block finally. 1. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, finally with arguments iteration second. Try statement. Try block catch finally. 1. If capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second is true, return true. 2. If capital C N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of catch with arguments iteration set and is true. Return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, finally with arguments iteration set and catch parameter block. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration set and function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item 1. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a module item list with arguments iteration set and 2. If has undefined labels is true, return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a module item with arguments iteration set and module item. Import declaration, export declaration, return false, point 4 function name inference, comma 4.1 static semantics, has name. The syntax directed operation has name takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N 1. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N 2. If as function definition of expa is false, return false. 3. Return whose name of expa, function expression, function, formal parameters, function body, capital G, generator expression, function, formal parameters, generator body, async generator expression, async function, formal parameters, async generator body, async function expression, async function, formal parameters, async function body. 18. ECMA International 2024. Arrow function, arrow parameters equals, concise body, async arrow function, async arrow binding identifier equals, async concise body, capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body class expression class tail return false function expression function binding identifier formal parameters function body generator expression function binding identifier formal parameters generator body async generator expression async function binding identifier formal parameters async generator body async function expression async function binding identifier formal parameters async function body class expression class binding identifier class tail return true, 4.2 static semantics is function definition. The syntax directed operation is function definition takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N 1. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N 2. Return is function definition of expa primary expression. This identifier reference literal, array literal, object literal, regular expression literal, template literal, member expression, expression, member expression. Identifier name member expression template literal super property, meter property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, ECMA International 2024 119. Update expression, left-hand side expression plus plus, left-hand side expression, plus plus unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative operator exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instantia of shift expression, relational expression in shift expression. Private identifier in shift expression, equality expression equals relational expression, equality expression, exclamation point equals relational expression, equality expression equals relational expression, equality expression equals relational expression, bitwise and expression and equality expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, logical and expression, and bitwise or expression, logical and expression, coalesce expression head, bitwise or expression, conditional expression, short circuit expression, assignment expression, 20, ECMA International 2024, assignment expression, yield expression, Left-hand side expression equals assignment expression. Left-hand side expression assignment operator assignment expression. Left-hand side expression and equals assignment expression. Left-hand side expression equals assignment expression. Left-hand side expression equals assignment expression. Expression assignment expression. Return false. Assignment expression. Arrow function. Async arrow function. Function expression. Function binding identifier opt. Formal parameters. Function body. Generator expression. Function binding identifier opt. Formal parameters. Generator body. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Class expression. Class binding identifier opt. Class tail 1. Return true, 4.3 static semantics is anonymous function definition. Expa. The abstract operation is anonymous function definition takes argument expa, an assignment expression parse node, an initializer parse node, or an expression parse node, and returns a boolean. It determines if its argument is a function definition that does not bind a name. It performs the following steps when called. 1. If as function definition of expa is false, return false. 2. Let hasName be hasName of expa. 3. If hasName is true, return false. 4. Return true, 4.4 static semantics is identifier ref. The syntax-directed operation is identifier ref takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, identifier reference, return true, ECMA International 2024 121. Primary expression, this, literal, array literal, object literal, function expression, class expression, generator expression, async function expression, async generator expression, regular expression literal, template literal, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Member expression, expression, member expression. Identifier name member expression template literal super property, meta property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, return false, 4.5 runtime semantics, named evaluation. The syntax-directed operation named evaluation takes argument name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, 1. Let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, 2. Return. Named evaluation of expa with argument name, parenthesized expression, expression 1. Assert is anonymous function definition, expression is true 2. Return. Named evaluation of expression with argument name, function expression, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N A R Y, capital F U N C T I O N, capital E X P, of function expression with argument name. Generator expression, function, formal parameters, generator body, return, capital I N S T A N T I A T E, capital G E N E R A T O R, capital F U N C T I O N, capital E X, of generator expression with argument name. Async generator expression, async function, formal parameters, async generator body, return, capital I N S T A N T I A T E, capital A S Y N C, capital G E N E R A T O R, capital F U N C T, of async generator expression with argument name. 22. Copyright sign, ECMA International 2024. Async function expression, async function, formal parameters, async function body. 1. Return, capital I N S T A N T I A T E, capital A S Y N C, capital F U N C T I O N, capital E X P R E S, of async function expression with argument name. Arrow function, arrow parameters equals, concise body, return, capital I N S T A N T I A T E, capital A R R O W, capital F U N C T I O N, capital E X P R E S, of arrow function with argument name. Async arrow function, async arrow binding identifier equals, async concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, equals, async concise body, return, capital I N S T A N T I A T E, capital A S Y N C, capital A R R O W, capital F U N C T I O N, capital E, of async arrow function with argument name. Class expression, class tail. 1. Let value be. Class definition, evaluation of class tail with arguments undefined and name. 2. Set value to the source text match by class expression. 3. Return value. 0.5 contains, 5.1 static semantics, contains. The syntax directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains. 1. For each child node child of this parse node. Do if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. 2. Return false. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, function expression, function binding identifier opt, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier opt, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, ECMA International 2024 123, async function expression, async function binding identifier opt, formal parameters, async function body, return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail, class heritage art, class body. 1. If symbol is class body, return true. 2. If symbol is class heritage, then if class heritage is present, return true, otherwise return false. 3. If class heritage is present, then if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block, static, class static block body. 1. Return false. Arrow function, arrow parameters equals, concise body. 1. If symbol is not one of new target, super property, super call, super, or this, return false. 2. If arrow parameters contain symbol is true, return true. 3. Return concise body contains symbol, arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. 1. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. 2. Return formals contain symbol, async arrow function, async arrow binding identifier equals, async concise body. 1. If symbol is not one of new target, super property, super call, super, or this, return false. 2. Return async concise body contains symbol, async arrow function, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body. 1. If symbol is not one of new target, super property, super call, super, or this, return false. 2. Let head be the async arrow head that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. 3. If head contains symbol is true, return true. 4. Return async concise body contains symbol, 24. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. 1. If symbol is method definition, return true. 2. Return the result of computed property contains of method definition with argument symbol, literal property name, identifier name, return false, member expression, member expression. Identifier name. 1. If member expression contains symbol is true, return true. 2. Return false, super property, super. Identifier name. 1. If symbol is the reserved word super, return true. 2. Return false, call expression, call expression. Identifier name. 1. If call expression contains symbol is true, return true. 2. Return false, optional chain. Identifier name. 1. Return false, optional chain, optional chain. Identifier name. 1. If optional chain contains symbol is true, return true. 2. Return false, 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions: class element name, private identifier, property name, literal property name, return false, property name, computed property name. Return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters. Function body, get class element name. Function body, set class element name, property set parameter list. Function body, return the result of computed property contains of class element name with argument symbol. Generate a method, class element name, unique formal parameters. Generate a body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method, async class element name, unique formal parameters. Async generator body, return the result of computed property contains of class element name with argument symbol. Class element list, class element list, class element. 1. Let in list be computed property contains of class element list with argument symbol. 2. If in list is true, return true. 3. Return the result of computed property contains of class element with argument symbol. Class element, class static block 1. Return false, class element. 1. Return false, async method, async class element name, unique formal parameters, async function body. 1. Return the result of computed property contains of class element name with argument symbol. Field definition, class element name initializer opt. Return the result of computed property contains of class element name with argument symbol. 6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, a function declaration with argument CNV and private env. Generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T E capital G E N E R A T O R capital F U N C T I O N capital O B of generator declaration with arguments env and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of async generator declaration with arguments env and private env. 26. ECMA International 2024. Async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return instantiate async function object of async function declaration with arguments env and private env8. 6. To runtime semantics, binding initialization. The syntax-directed operation binding initialization takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier, identifier 1. Let name be string value of identifier 2. Return. Initialize bound name, name, value, environment, binding identifier, yield, return. Initialize bound name, yield, value, environment, binding identifier, await, return. Initialize bound name, await, value, environment, binding pattern, object binding pattern 1. Perform. Require object coercible, value 2. Return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern, array binding pattern 1. Let iterator record be. Get iterator, value, sync 2. Let result be completion, iterator binding initialization of array binding pattern with arguments iterator record and environment 3. If iterator record is false, return. Iterator close, iterator record, result 4. Return result, object binding pattern 1. Return unused, object binding pattern, binding property list 1. Perform. Property binding initialization of binding property list with arguments value and environment 2. Return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern, binding rest property 1. Let excluded names be a new empty list 2. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern, binding property list, binding rest property 1. Let excluded names be. Property binding initialization, a binding property list with arguments value and environment 2. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names, 6. 2. 1. Initialize bound name, name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding name, value, be return unused, else a let LHS be. Resolve binding, name be return. Put value, LHS, value, 6.3 runtime semantics, iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. 1. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. 2. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. 1. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. 2. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding L is an element. Elision binding element. 1. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 2. Return. Iterator binding initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. 1. Let binding id be string value of binding identifier. 2. Let LHS be. Resolve binding. Binding id Environment. 3. Let v be undefined. 4. If iterator record is false, then a let next be. Iterator step value. Iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v to named evaluation of initializer with argument binding id b. Else I let default value be. Evaluation of initializer 2. Set v to get value, default value 6. If environment is undefined, return put value LHS v7. Return initialize reference binding LHS v binding element binding pattern initializer opt 1. Let v be undefined. 2. If iterator record is false, then a let next be. Iterator step value. Iterator record b. If next is not done, then I set v to next. 3. If initializer is present and v is undefined, then a let default value be. Evaluation of initializer b. Set v2. Get value, default value 4. Return binding initialization of binding pattern with arguments v and environment binding rest element binding identifier 1. Let LHS be. Resolve binding string value of binding identifier environment 2. Let a be. Array create 0 3. Let 0 4. Repeat a let next be done b. If iterator record is false, then I set next 2. Iterator step value. Iterator record c. If next is done, then ECMA International 2024 129. I. If environment is undefined, return put value LHS a 2. Return initialize reference binding LHS a d. Perform create data property or throw a to string n next e. Set n to n plus 1 binding rest element binding pattern 1. Let a be. Array create 0 2. Let 0 3. Repeat a let next be done b. If iterator record is false, then I set next 2. Iterator step value. Iterator record c. If next is done, then I return binding initialization of binding pattern with arguments a and environment d. Perform create data property or throw a to string n next e. Set n to n plus 1 formal parameters empty 1. Return unused formal parameters formal parameter list function rest parameter 1. Perform iterator binding initialization of formal parameter list with arguments iterator record and environment 2. Return iterator binding initialization of function rest parameter with arguments iterator record and environment formal parameter list formal parameter list formal parameter 1. Perform iterator binding initialization of formal parameter list with arguments iterator record and environment 2. Return iterator binding initialization of formal parameter with arguments iterator record and environment arrow parameters binding identifier 1. Let v be undefined 2. Assert iterator record is false 3. Let next be. Iterator step value. Iterator record 4. If next is not done, then a set v to next. Return binding initialization of binding identifier with arguments v and environment arrow parameters capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N 1. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N 2. Return Iterator binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier. Binding identifier 1. Let v be undefined. 2. Assert. Iterator record is false. 3. Let next be. Iterator step value. Iterator record. 4. If next is not done, then asset v to next. Return. Binding initialization of binding identifier with arguments v and environment. 30. ECMA International 2024. 6.4 Static Semantics. Assignment target type. 3. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 08. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top-level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return the top-level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top-level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 Static semantics. Top-level var scope declarations. The syntax-directed operation top-level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let declarations 1 be top-level var scope declarations of statement list. 2. Let declarations 2 be top-level var scope declarations of statement list item 3. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top-level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. B return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the top-level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top-level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. ECMA International 2024 109.3 labels, 3.1 Static semantics. Contains duplicate labels. The syntax-directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item. Declaration. Return false. Statement list. Statement list. Statement list item 1. Let has duplicates be contains duplicate labels of statement list with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate labels of statement list item with argument label set. If statement, if, expression statement, else statement 1. Let has duplicate be contains duplicate labels of the first statement with argument label set. 2. If his duplicate is true, return true. 3. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, 4. Expression not, expression not, expression not statement, 4. var variable declaration list. Expression not, expression not statement 4. Lexical declaration expression not, expression not statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement 4. Left-hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. var for binding of assignment expression statement 4. For declaration of assignment expression statement. For await, left-hand side expression of assignment expression statement for await, var for binding of assignment expression statement for await. For declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement with expression statement. Return contains duplicate labels of statement with argument label set. Switch statement, switch, expression, case block. Return contains duplicate labels of case block with argument label set. Case block 1. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set as true, return true. 2. If contains duplicate labels of default clause with argument label set as true, return true. 3. If the second case clauses is not present, return false. 4. Return contains duplicate labels of the second case clauses with argument label set. Case clauses, case clauses, case clause 1. Let has duplicates be contains duplicate labels of case clauses with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of case clause with argument label set. Case clause, case expression, statement list opt. 1. If the statement list is present, return contains duplicate labels of statement list with argument label set. 2. Return false. Default clause, default, statement list opt. 1. If the statement list is pre-sent, return contains duplicate labels of statement list with argument label set. 2. Return false. Labeled statement, label identifier, labeled item. 1. Let label be the string value of label identifier. 2. If label set contains label, return true. 3. Let new label set be the list concatenation of label set and label. 4. Return contains duplicate labels of labeled item with argument new label set. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. 1. If contains duplicate labels of block with argument label set as true, return true. 2. If contains duplicate labels of catch with argument label set as true, return true. 3. Return contains duplicate labels of finally with argument label set. Catch, catch, catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list, module item list, module item, 1. Let has duplicates be contains duplicate labels of module item list with argument label set. 2. If has duplicates is true, return true. 3. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. 1. Let has undefined labels be contains undefined break target of statement list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of statement list item with argument label set. If statement, if, expression statement, else statement. 1. Let has undefined labels be contains undefined break target of the first statement with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of the second statement with argument label set. If statement, if expression statement, return contains undefined break target of statement with argument label set. Do while statement, do statement while. Expression, return contains undefined break target of statement with argument label set. While statement, while. Expression statement, return contains undefined break target of statement with argument label set. For statement, 4. Expression not statement, 4. var variable declaration list. Expression not statement 4. Lexical declaration expression not statement, return contains undefined break target of statement with argument label set. For in of statement, 4. Left-hand side expression in expression statement, 4. var for binding in expression statement, 4. For declaration in expression statement, 4. Left-hand side expression of assignment expression statement, 4. var for binding of assignment expression statement, 4. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement, for await. For declaration of assignment expression statement, return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5 Break statement, break. 1. Return false, ECMA International 2024 113. Break statement, break label identifier. 1. If label set does not contain the string value of label identifier, return true. 2. Return false, with statement, with expression statement, return contains undefined break target of statement with argument label set. Switch statement, switch, expression, case block, return contains undefined break target of case block with argument label set. Case block, return false, case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, then, if contains undefined break target of the first case clauses with argument label set as true, return true. 2. If contains undefined break target of default clause with argument label set as true, return true. 3. If the second case clauses is not present, return false. 4. Return contains undefined break target of the second case clauses with argument label set. Case clauses, case clause 1. Let has undefined labels be contains undefined break target of case clauses with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of case clause with argument label set. Case clause, case expression, statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false, default clause, default, statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false, labeled statement, label identifier, labeled item. 1. Let label be the string value of label identifier. 2. Let u label set be the list concatenation of label set and label. 3. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. 1. If contains undefined break target of block with argument label set as true, return true. 2. If contains undefined break target of catch with argument label set as true, return true. 3. Return contains undefined break target of finally with argument label set. Catch parameter, block. Return contains undefined break target of block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list, module item list, module item, 1. Let has undefined labels be contains undefined break target of module item list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 static semantics. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. The syntax directed operation. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. A block statement with arguments iteration set and ECMA International 2024 115. Breakable statement, iteration statement 1. Let new iteration set be the list concatenation of iteration set and label set. 2. Return, capital C O N T A I N S, capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of iteration statement with arguments new iteration set and statement list. Statement list item 1. Let has undefined.
What's with all
O N T A I N
the fucking redundancy
N
in the stupid shit
E
with the fucking GPU for fucking fuck?
E
Fucking fuck. I don't give a fucking fuck.
N
What does this do? It validates the fucking file?
E. Capital
It doesn't make the file?
R.
Or some shit? Why do I even need this?
List with argument
Why?
2
Chatbot's like,
is true.
it does make the file. Okay, so I have to like
Capital C O N T
fucking make the file in advance,
capital E
manually,
D
fucking typing it in, and then it makes the fucking SPV file
C
from the frag and the GLSL file.
N U
So this is like the frag file
A
here, number 450, right?
of state
This is the invert SPV file that I make when I make it, when I fucking click the fucking compiler. When I fucking I can't even say my words, it's so stupid. When I click to compile it
N
in the terminal,
capital U
it makes invert the SPV, okay?
I N E
This is invert.spv from invertfrag 450 here. Shows up in here.
E capital T A R G E of the first statement with argument.
It literally just makes the text file into fucking binary.
Return true. 3.
But it's not binary, it just made it to like a pseudo text file.
I
It didn't fucking do anything.
capital U
It didn't transform the fucking data.
F
It's pointless. It's a pointless fucking step.
capital
A waste of fucking time.
N T I
And then this validate thing, whatever the fuck it is,
capital T A
in the fucking make file.
E of the second statement with arguments iteration second if statement if expression statement return capital C O N T A I N S capital U
It takes
B E F I N E D
the SPV file
O N
and the fragment shader file,
I N
makes a directory,
E
whatever
capital
the fuck P does,
A R
GSlang validator,
with arguments iteration set
so GL source language validator.
and capital
It validates the fucking file,
T A
and then it makes a new file, but the new file
capital U N D E F I
is the same exact motherfucking thing as this file. There's no difference in the fucking file.
N U
I can go to the last line, I can select it,
A
I can do Control F.
E of
It shows up the fucking same. I can literally get rid of all the new lines. What the hell is a new line doing in a binary file? It's supposed to be like, quote, binary. Why is there a new line in here? It's like literally, the text is made into fucking
A N
Unicode characters without the fucking text encoding.
N
It's stupid.
U E
I can get rid of the new lines.
A R
And I'm willing to bet
E of state
that's gonna be the same exact motherfucking thing.
4 expression
This is such a waste of fucking time. Holy fuck.
var variable declaration
These video card companies are fucking idiots.
4 lexical declaration
They waste so much of everyone's time.
return
Stupid fucking video cards.
N T A I
Made up fucking
U
fucking everything.
F
So fucking fake.
C
And pointless. Holy fuck.
T I N U E
So I got rid of all new lines.
R
Control All.
E of statement with arguments iteration
Control F. Now is it a match?
4 left hand
I do find next.
statement 4
Oh my god, would you look at that? Even in this file.
declaration in expression statement 4
One match.
side
It's the fucking same.
var for binding
Why the fuck can't the video card do this on the goddamn motherfucking video card? It doesn't even do anything.
left hand side
It literally just changed the fucking text to a different fucking format and then it validated it and made a fucking copy from A to B.
statement return capital
What's the fucking point?
T
It's wasting my time. I have to physically make an extra fucking file. Go to the fucking command line, type it in, run it, and I gotta like make this fucking. Oh my fucking god!
C O
This is dumb as fuck. Fucking idiotic.
U
Holy shit.
T
This is wasting so much fucking time.
E
Fuck.
button. Note this section.
This video card stuff is fuck tartary, for fuck's sake.
Continue. 1
Holy fuck. There's so many pointless. Why?
new statement
Holy shit, this is dumb.
if iteration
I just want to make a fucking triangle.
view of label identifier
I
return
don't want to compile pointless files that regenerate to the same fucking file as the fucking file that came from. What the fuck?
N
It's stupid. Is that not stupid? Does that make sense? What the fuck?
E D
The chatbot's like,
O N T I N U E.
I totally get the confusion. If it makes SPV, then why do I need to tell it to output an SPV if it's already an SPV? Holy fuck! Here's the clear truth.
Block. Return. Capital
Think of it as source code. It's not source code. It's the same fucking file. What the fuck?
capital U
It doesn't transform anything.
E
Nothing changes.
I
It says you cannot feed directly. It must be compiled. Oh my god.
T I N U E
This is so fucking stupid.
G E
Just because it's a file extension, it's not magic. It means it needs the input is already in.
full
It's the same file.
case clauses is present, then A
Oh, this is so dumb.
O N T
It says GSLing would print the binary to SC out or just save it all, which is useless.
E F I
If you don't specify this, then it would print the same binary.
N U E capital
If you didn't specify -o, SPV,
first case clauses with arguments iteration set and is true.
which is here,
If capital C O
would print the binary to SC out or just not save it at all, which is useless.
S capital U
You must give blah 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 to the compiler,
N
tell the compiler what SPV to write out. SPV is the actual binary.
T
It's the same file.
E capital T
You give a GSL. Why am I giving it
of default
if it's the same file?
is true. Return true 3. If the second case clause return
What the fuck?
C O N T
It's machine readable binary. It's not machine readable binary.
N D E
The machine does not execute this. This is not instruction set architecture.
O
That's so misleading. It's misleading as fuck. This is a fucking pseudocode. The video card manufacturers are fucking ridiculous.
second
They're making it look like it does something that it doesn't.
case clause
Holy fuck. Bunch of fucking fakes.
symbols be capital C
It's so fucking dumb.
T A I N S capital U
I'm gonna ask it to do this.
F I N E D capital C O N T I N U E capital T A R G E of case clauses with arguments iteration set and 2. If has undefined labels is true, return true 3. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case clause with arguments iteration set and dart case clause case expression statement list opt 1. If the statement list is present, return capital C O N T A I.
I'm telling Chatbot, show me this. I'll show you the compiled machine code readable binary. And I'm saying, so you mean by machine code readable binary that the GPU executes it directly without translation to an intermediate machine code that's fed to the CPU.
A R
Because that's not fucking machine code.
list with arguments
It's not even machine readable binary.
default clause
It's a fake fucking file format.
stopped 1. If the
Oh, here we go. Great follow-up. Let's clarify what machine readable binary means in the context of SPV in Vulkan.
S
What it actually is, it told me what it is, and it's being misleading, and it's like, oh, let me clarify, because you're being specific and you know what you're talking about.
E
For fuck's sake,
T
this is so dumb.
N
Standard portable intermediate representation.
R G
It's the same thing as the fucking text file. You can see half of it because it doesn't change,
identify
because it's already a number.
1. Let
The only things that are changed are the fucking text.
fire 2.
This is so stupid.
Set and label 3. Return capital C O N T A I N S capital U N
It's a binary intermediate language, not plain text.
N E
It's not GPU specific. Machine code like x86 or SAS, well then it's not machine code.
U
It's not directly executable by the GPU hardware as is.
G E
Oh, it's so pointless.
arguments
Instead, it's hardware independent intermediate format optimized for drivers to ingest.
try block catch 1.
It's a goddamn text file
Capital C O
with a different formatting.
T A I N S
It literally has new lines in it to make it human readable still.
F I
This is stupid as fuck.
D capital C O N T I N U E capital T A R G E a block with arguments iteration set and 2. If has undefined labels is
It's binary, not text.
true. Return
It's fucking text.
O
The Vulkan driver parses it, not the CPU.
I N
Not directly. It will translate it to CPU, GPU specific code at runtime.
N
Oh my god, it's JIT compiled? Oh, that's terrible.
N
That's horrible.
I N
The GPU runs off JIT?
capital
It runs off JIT compilation?
R G E of cat
That's shitty.
Second, ECMA International 2024 117. Try statement. Try block finally. 1. Let has undefined labels be capital C O N T A I N S capital
That's probably like out of context too.
E F I
If I asked it what do you mean by JIT, it'd probably say, let's clarify what I mean by JIT.
N T I N U E
It says you compile shader to shader.
R
That's not what's happening though. I'm supplying shader SPV also.
and labels is true. Return true. 3. Return capital C O N T A I N S capital U N D E F I
It's not human readable.
D
I can find the number 420 right inside of it.
I
I go over to here,
U E
I type in 450,
P A
and I go over to here,
E
fucking 450. Ta-da! It literally just added a little bit of text here to say it meets some standard,
O N
that it meets 450.
N S
So it just inserted a couple letters here.
D
And it made sure that it is human readable. Because it's fucking, this converts to something that you can do by hand if you want to waste your fucking time.
I N
It's not machine readable.
capital T A R G E a block with arguments iteration set and is true. Return true. 2. If capital C O N T A I N
Right here, it says it takes,
capital U N D E
do I even need
I N
to do whatever the fuck this is? GSL, lang validator.
I N U E capital T A R
I'm gonna skip that step.
E of catch with arguments iteration set and is true. Return true. 3. Return capital
I think it just compares the shader to the fucking
I N S
fragment file, whatever. It's just comparing them, and it's pooping out the same exact file
N
that has what's going on.
capital C O N T I
So I'm gonna delete these.
U E, capital T, A, R, G, E, finally with arguments iteration second, catch parameter, block, return, capital C, O, N, T, A, I,
I'm gonna click build, see if it makes some.
capital U, N, D, E, F, I, N, E, D, capital C, O, N, T,
So now I'm gonna delete these.
U, E, capital T, A, R, G, E, a block with arguments iteration second, function statement list,
I'll edit the makefile to remove this part.
false, class static block statement list, empty, 1. Return false, modulitem list, modulitem 1. Let has undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, a modulitem list with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T.
Okay, so I'm gonna need the vertex and this one after I run it to make sure it doesn't actually do anything, because it's not actually doing anything. Oh my fucking god, this is a waste of fucking time.
Return false.
I'm gonna run it.
Name inference, 4.1 static semantics, has name.
So no rules needed, it didn't make it.
Has name takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, 1.
Really?
Be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, 2. If as function definition of expr is false, return false. 3. Return his name of expr, function expression, function, formal parameters, function body, generator expression, function, formal parameters, generator body, async generator expression, async function, formal parameters, async generator body, async function expression, async function, formal parameters, async function body. 18. ECMA International 2024. Arrow function, arrow parameters equals, concise body, async arrow function, async arrow binding identifier equals, async concise body, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body, class expression,
So it didn't make the files,
function expression,
and the program somehow runs even though they're not there.
body, generator expression, function binding identifier, formal parameters, generator body, async generator expression, async function binding identifier, formal parameters, Async generator body, async function expression, async function binding identifier, formal parameters, async function body, class expression, class binding identifier, class tail, return true, 4.2 static semantics is function definition. The syntax directed operation is function definition.
This is loading it from shader/vert,
Piecewise over the following productions. Primary
the original folder path.
O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N1. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N2. Return is function definition of expa. Primary
Is it even calling this function?
Fire reference literal, array literal, object literal, regular expression literal, template literal, member expression, member expression, expression, member expression, identifier name, member expression, template literal, super property, meter property, new member expression, arguments, member expression, private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, ECMA International 2024 119, update expression, left-hand side expression plus plus, left-hand side expression, plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative. Multiplicative expression, multiplicative operator, exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instantia of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression equals relational expression, equality expression equals relational expression, equality expression equals relational expression, equality expression equals relatio, null expression, bitwise and expression and equality expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, logical and expression.
What?
Bitwise or
Why isn't it throwing an error then?
logical or expression.
Oh, this is so dumb.
Coalesce expression head. Bitwise or expression, conditional expression, short circuit expression, assignment expression, 20, ECMA International 2024, assignment expression, yield expression, left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, assignment expression, return false, assignment expression, arrow function, async arrow function, function expression, function binding identifier opt, formal parameters, function body, generator expression, function binding identifier opt, formal parameters, generator body, async generator expression, async function binding identifier opt, formal parameters.
I'm gonna paste fucking shaders,
Expression,
SPV, whatever the fuck files.
formal parameters.
Into here.
Body. Class expression. Class binding identifier. Class tail1. Return true, 4.3 static semantics is anonymous function definition. Expa. The abstract operation is anonymous function definition takes argument expa, an assignment expression parse node, an initializer parse node, or an expression parse node, and returns a boolean. It determines if its argument is a function definition that does not bind a name. It performs the following steps when called. 1. If as function definition of expa is false, return false. 2. Let hasName be hasName of expa. 3. If hasName is true, return false. 4. Return true, 4.4 static semantics is identifier ref. The syntax-directed operation is identifier ref takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, identifier reference, return true, ECMA International 2024 121. Primary expression, this, literal, array literal, object literal, function expression, class expression.
So it is entering and loading.
Async function expression, async generator expression, regular expression literal, template literal.
So princess.
O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Member expression, expression, member expression. Identify name member expression template literal super property, meter property, new member expression arguments member expression.
It passes a different name. It doesn't exist.
Side expression, call expression, optional expression, return false, 4.5 runtime semantics, named evaluation, the syntax.
So it failed to open the file.
Takes argument name.
Why doesn't it check the path?
Key or
The fucking type.
either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E,
This has to just copy it.
X, P, R, E, S, S, I, O, N, capital A, N, 1. Let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A,
It says no. The rule like this in your makefile.
E,
It does not copy, it compiles.
Z, E, D, capital E, X,
Then why is the file exactly the same byte for byte?
I, O, N, capital
The .s, whatever the fuck it is,
of X,
spv
parenthesized expression, expression 1.
is exactly the fucking same.
Expression is true. 2. Return. Named evaluation of
It's spv that I put in.
expression, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital E.
How am I misunderstanding the process?
Name. Generator expression. Function.
Holy fuck.
To body. Return. Capital I, N, S, T, A, N, T, I, A, T, E, capital G, E,
Holy fuck.
A, T, O, R, capital
It's starting to piss me off now.
N, C, T, I, O,
If I go into here,
capital E, X,
shaders, and if I delete, invert, invert, SPV.
Async function, formal parameters, async generator body, return, capital I, N, S, T, A, N, T, I, A,
Move to trash. Now when I run it,
capital A, F,
I already fixed this to red path.
C, capital
When I run it,
N, E, R, A, T,
I guess it builds all of a sudden. Okay, never mind.
C, T, of async generator,
Well, that's fucking annoying.
copyright sign, ECMA int.
So am I safe to delete these? Will it still work?
Async function, formal parameters, async function body,
Oh, it's because I
I,
took out the code that does it.
T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, of async function expression
Oh, it's working now? Wow, okay.
is equals concise body return capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P.
Well, at first it wasn't doing that. I guess it does do it then.
Argument name async arrow function async arrow binding identifier equals async concise body
So I don't know why it's throwing a warning when I delete them from here, but now it works.
capital
But still, this fucking output file,
L
it's weak as fuck.
X P R E S
It doesn't even fucking convert it. It's fucking human readable.
A N D cap
It's stupid. It's pointless.
N C capital A R R equals async concise body return capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E of async arrow function
And why does it have to be done CPU side? Why can't the GPU do it?
1
It's just wasting CPU time.
evaluation of class tail with arguments undefined and name 2 force text match by class expression 3 return value point
This is dumb.
5.1 static semantics contains the syntax directed operation contains takes argument symbol a grammar symbol and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains 1 for each child node child of this parse node do if child is an instance of symbol return true b if child is an instance of a non-terminal then I let contained be the result of child contains symbol 2 if contained is true return true 2 return false function declaration function binding identifier formal parameters function body function formal parameters function body function expression function binding identifier
Hurry back up.
body generator declaration function binding
I'm gonna paste into these.
generator body function formal parameters generator body generator expression
Why is it gonna open it across multiple places?
generator body async generator declaratio n async function binding identifier formal parameters async generator body async function formal parameters async generator body async generator expression async function binding identifier formal parameters async generator body async function declaration async function binding identifier formal parameters async function body Async function. Formal parameters. Async function body. ECMA International 2024 123. Async function expression. Async function binding identifier. Formal.
I'm gonna copy paste from
And false. Note 1 static
whatever's Vulkan tutorials.
Substructure generally do not look into function definitions. Class tail. Class heritage art. Class body.
Wherever it was.
Return
Who the heck, whatever.
is class heritage. Then, if class heritage is
This one. Copy paste those structs, or not structs, fucking files over
then, if class heritage contains symbol is true.
into the other shader files.
Computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals. Concise body. 1. If symbol is not one of new target. Super property.
I want a red triangle, or a rainbow triangle. I think it's a rainbow triangle now.
Parameters contain.
Should make a rainbow triangle.
3. Return concise.
Probably won't.
Arrow parameters. Capital C O V E R. Capital P A R.
Now why is it not fucking...
T H E S I Z E D. Capital E X P R E S S I O N. Capital A N 1. Let formals be the array formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N 2. Return formals contains symbol. Async arrow function. Async arrow binding identifier equals. Async concise body. 1. If symbol is not one of new target. Super property. Super call. Super. Or this. Return false. 2. Return async concise body contains symbol. Async arrow function. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals. Async concise body. 1. If symbol is not one of new target. Super property. Super call. Super. Or this. Return false. 2. Let head be the async arrow head that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. 3. If head contains symbol is true, return true. 4. Return async concise body contains symbol. 24. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. 1. If symbol is method definition, return true. 2. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. 1. If member expression contains symbol is true, return true. 2. Reto RN false. Super property. Super. Identifier name. 1. If symbol is the reserved word super, return true. 2. Return false. Call expression. Identifier name 1. If call expression contains symbol is true, return true. 2. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Identifier name 1. If optional chain contains symbol is true, return true. 2. Return false, 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier.
Did I miss that when I was typing it up?
Name, return false, property name, computed property name. Return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters. Function body, get class element name. Function body, set class element name, property set parameter list. Function body, return the result of computed
ID.
of class element name with argument symbol. Generate a method, class element name, unique formal parameters. Generate a body, return the result of
It says in, not out. That's what I missed.
National 2024-125. Async generator method. Async class element name. Unique formal.
Oh, this sucks, dick.
Return the result of computed property contains of class element name with argument symbol. Class element list. Class element list. Class element 1. Let in list be computed.
No triangle. Still no triangle.
2. If in list is true.
Man.
3. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name. Unique formal parameters. Async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initial is a rot. Return the result of computed property contains of class element name with argument symbol. 0.6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, a function declaration with argument CNV and private env. Generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with argument CNV and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of a sync-generated declaration with arguments env and private env. 26. ECMA International 2024. A sync function declaration. A sync function binding identifier. Formal parameters. A sync function body. A sync function. Formal parameters. A sync function body. Return instantiate a sync function object of a sync function declaration with arguments env and private env8. 6. To runtime semantics. Binding initialization. The syntax-directed operation binding initialization takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier. Identifier 1. Let name be string value of identifier. 2. Return. Initialize bound name. Name. Value. Environment. Binding identifier. Yield. Return. Initialize bound name. Yield. Value. Environment. Binding identifier. Await. Return. Initialize bound name. Await. Value. Environment. Binding pattern. Object binding pattern. 1. Perform. Require object coercible. Value. 2. Return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern. Array binding pattern. 1. Let iterator record be. Get iterator. Value. Sync. 2. Let result be completion. Iterator binding initialization of array binding pattern with arguments iterator record and environment. 3. If iterator record is false, return. Iterator close. Iterator record. Result. 4. Return result. Object binding pattern. 1. Return unused. Object binding pattern. Binding property list. Binding property list. 1. Perform. Property binding initialization of binding property list with arguments value and environment. 2. Return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding rest property. 1. Let excluded names be a new empty list. 2. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. 1. Let excluded names be. Property binding initialization of binding property list with arguments value and environment. 2. Return. Rest binding initializer. Tion of binding rest property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name. Name. Value. Environment. The abstract operation initialize bound name takes arguments name, a string, value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding name value be return unused, else a let LHS be resolve binding name be return put value LHS value, 6.3 runtime semantics. Iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, A collision with argument iterator record. Array binding pattern. Eligilant binding rest element. If collision is present, then a perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A collision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A collision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Eligilant binding rest element. 1. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. 2. If elision is present, then a perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A collision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. 1. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. 2. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. 1. Perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. Of elision with argument iterator record. 2. Return. Iterator binding initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. 1. Let binding id be string value of binding identifier. 2. Let LHS be resolve binding. Binding id environment. 3. Let v be undefined. 4. If iterator record is false, then a let next be iterator step value. Iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition initializer is true, then I set v to named evaluation of initializer with argument binding id b. Else I let default value be evaluation of initializer. 2. Sem v to get value default value. 6. If environment is undefined, return put value LHS v7. Return initialize reference binding LHS v binding element binding pattern initializer opt. 1. Let v be undefined. 2. If iterator record is false, then a let next be iterator step value iterate to record. B, if next is not done, then I set V to next. 3. If initializer is present and V is undefined, then I let default value be. Evaluation of initializer, B set V2. Get value, default value, 4. Return. Binding of binding pattern with argument.
Oh my god, this shit is stupid as fuck.
Binding identifier, 1. Let LHS be. Resolve binding. String value of binding identifier. Environment, 2. Let A be. Array create, 0, 3. Let 0, 4. Repeat, let next be done. B if iterate a record is false. Then I set next 2. Iterate a step value. Iterate to record C if next is done. Then ECMA International 2024 129. I if environment is undefined. Return. Put value. LHS A 2. Return. Initialize reference binding. LHS A deperform. Create data property or throw A to string N. Next, ESET N to N plus 1. Binding rest element. Binding pattern 1. Let A be. Array create 0, 2. Let 0, 3. Repeat, let next be done. B if iterate a record is false. Then I set next 2. Iterate a step value. Iterate to record C if next is done. Then I return. Binding initialization of binding pattern with arguments A and environment. Deperform. Create data property or throw A to string N. Next, ESET N to N plus 1. Formal parameters. Empty 1. Return unused. Formal parameters. Formal parameter list. Function rest parameter 1. Perform. Iterate a binding initialization of formal parameter list with arguments iterator record and environment 2. Return. Iterate a binding initialization of function rest parameter with arguments iterator record and environment. Formal parameter list. Formal parameter list. Formal parameter 1. Perform. Iterate a binding initialization of formal parameter list with arguments iterator record and environment 2. Return. Iterate a binding initialization of formal parameter with arguments iterator record and environment. Arrow parameters. Binding identifier 1. Let V be undefined 2. Assert. Iterate a record is false 3. Let next be. Iterate a step value. Iterate a record 4. If next is not done, then set V to next. Return. Binding initialization of binding identifier with arguments V and environment. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N 1. Let formals be the array formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N 2. Return. Iterate a binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier. Binding identifier 1. Let V be undefined 2. Assert. Iterate a record is false 3. Let next be. Iterate a step value. Iterate a record 4. If next is not done, then set V to next. Return. Binding initialization of binding identifier with arguments V and environment. 30. ECMA International 2024. 6.4 Static semantics. Assignment target type.
this is so boring.
Grave accent. Three. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list.
Alright, so. Really? The sound is to stop working? Okay. Should restart the fucking program.
Declarations are treated like var declarations rather than like lexical declarations. Statement list item. If statement is statement.
Okay, so basically,
Names of statement.
I'm gonna like leave everything how it is.
Note at the top level of a function or script.
It'd be nice to like have it do all the files in the folder, but I don't know why it's not working. I don't give a shit about a makefile.
Return the top level.
I don't care to figure it out. I just want it running. That's all I want. Oh my god.
Statement. Return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top level var scope declaration.
So basically,
Operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item 1. Let declaration.
it does actually make the SPV files, even though they're basically human readable. They're not even for the machine directly.
Item 3. Return the list concatenation of.
It doesn't matter, I'm not going to go to the file. But it does make them. I thought that it had to be compiled beforehand, because for some reason,
Top level var scope
that's why I did it.
declarations of.
So because, okay, whatever.
If declaration is
Something else was looking to this folder in those files,
declaration be declaration
and that's why I was getting stuck. Not because this got stuck on making them.
list labeled
It
statement
was because of another thing that's fixed now.
item. Return the top level var scope declarations of labeled item.
But now it does actually make the fucking shader file.
If statement is statement.
So I changed it to,
Top level var scope declarations of statement.
I'm gonna leave it the same, whatever, so it does make the file.
Of statement labeled item. Function declaration 1. Return function declaration. ECMA International.
Come on.
Point 3 labels, 3.1 static semantics. Contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement.
No, it doesn't make the file, it's not making the file.
Continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item. Declaration. Return false. Statement list. Statement list. Statement list item 1. Let has duplicates be
Why does it need to open? Fuck.
set 2. If has duplicates
Why is it making the files after it builds the executable?
labels of
This is so annoying. This is literally the most annoying shit, for fuck's sake. Oh my fucking god.
B contains duplicate labels of the first statement with argument label set 2. If has duplicate is true,
What the bull?
duplicate labels of the second statement with argument label set. If statement, if expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains
I
duplicate.
can't take it. I can't fucking take it. Oh my fucking shit.
4. Expression not. Expression not. Expression not statement. 4. Var variable declaration list. Expression not. Expression not statement 4.
Oh, it's these, okay.
Not. Expression not statement. Return
Please let this be it. Let this be it.
argument label set. 10. ECMA International 2024. Side expression in expression statement 4. Var for binding in expression statement 4. For declaration in expression statement 4. Left hand side expression of assignment expression statement 4.
It's back to where it was.
Assignment expression statement 4. For declaration.
Why?
Statement.
Why? Why?
Expression of assignment expression. Finding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section.
Okay, so now I made the files right there.
3.5 with statement with expression statement. Return contains duplicate.
I can't take it. It's just so stupid.
Switch.
Fucking cares.
Expression
Running.
contains duplicate labels of case block with argument label set. Case block 1. Return false. Case block. Case clause assopt. Default clause. Case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case.
Okay, can I delete these now?
That is true.
Is it gonna run?
If
Will it make?
clause with argument label set is true.
Fail to open shader.
The second case clauses is not present. Return false. 4. Return contains duplicate labels of the second case clauses with argument label set. Case clauses.
Fail to open shader.
Case clause 1.
Fail to open shader.
Be contained of case clauses with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate.
Well, how did it do it last time?
Case clause.
Just out of nowhere, it decided to work.
Statement list opt. 1. If the statement list is present, return statement list with argument label set. 2. Return false. Default clause. Default state is pre-sent. Return contains duplicate labels of statement list with.
I hate chatbot. I fucking hate chatbot. I fucking hate chatbot. Holy fuck, I hate chatbot.
Value of label identifier. 2.
It said that I don't need these,
Return true. 3.
but I fucking do apparently.
4. Return contains
Yeah.
argument new label set. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has duplicates be contains duplicate labels of block with argument label set. 2.
So it builds the files, I think, hopefully. There we go, finally.
Catch with argument label set. Try statement. Try.
Don't delete them again.
Let has duplicates be contains duplicate labels of block with argument label set. 2. If his duplicates is true, return true. 3. Return contains duplicate.
I'm gonna redo back to what it was from the triangle file
1. If
tutorial thing,
labels of block with argument
which was this
return true. 2.
and this, but this had to be in.
Labels of catch with argument label set is true. Return.
So now it's making the shaders
Return contains
to make the goddamn triangle,
with argument label set. Catch
or it should, and it should output them in this file folder,
contains duplicate.
this folder.
Argument label set. Function statement list. Empty. 1. Return false. Class static.
And no triangle.
1. Return false. Module item list. Module item list. Module item 1. Let has duplicates be contains duplicate labels of module item list with.
I'm gonna paste the whole thing into chatbot and ask chatbot to fix it.
Return true. 3. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. 1. Let has undefined labels be contains undefined break target.
Oh man.
Argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement else statement. 1. Let has undefined labels be contains undefined break target of the first statement with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of the second statement with argument label set. If statement, if expression statement, return contains undefined break target of statement with argument label set. Do while statement, do statement while. Expression, return contains undefined break target of statement with argument label set. While statement, while. Expression statement, return contains undefined break target of statement with argument label set. For statement, 4. Expression not, expression not, expression not statement, 4. The variable declaration list, expression not, expression not statement 4. Lexical declaration expression not. Expression not statement, return contains undefined break target of statement with argument label set. For in of statement, 4. Left-hand side expression in expression statement, 4. var for binding in expression statement, 4. For declaration in expression statement, 4. Left-hand side expression of assignment expression statement, 4. var for binding of assignment expression statement, 4. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement for await. For declaration of assignment expression statement, return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5 break statement, break. 1. Return false. ECMA International 2024 113. Break statement. Break label identifier. 1. If label set does not contain the string value of label identifier, return true. 2. Return false. With statement. With expression statement, return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set as true, return true. 2. If contains undefined break target of default clause with argument label set as true, return true. 3. If the second case clauses is not present, return false. 4. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses case clause. 1. Let has undefined labels be contains undefined break target of case clauses with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false. Default clause. Default. Statement list opt. 1. If the statement list is present, return contains undefined break target of statement list with argument label set. 2. Return false. Labeled statement. Label identifier. Labeled item. 1. Let label be the string value of label identifier. 2. Let n, u label set be the list concatenation of label set and label. 3. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. 1. Let has undefined labels be contains undefined break target of block with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. 1. If contains undefined break target of block with argument label set as true, return true. 2. If contains undefined break target of catch with argument label set as true, return true. 3. Return contains undefined break target to finally with argument label set. Catch parameter, block. Return contains undefined break target to block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list, module item list, module item, 1. Let has undefined labels be contains undefined break target of module item list with argument label set. 2. If has undefined labels is true, return true. 3. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 statics and
Did Jeppa even change the thing, the file, whatever?
T A I N S capital U N D E F
Still no triangle.
E D capital C O N T I N U E capital T A R G E. The syntax directed operation capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E.
Seems almost at 12 hours.
Strings and labels.
Just start another one.
Turns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A block statement with arguments iteration setend. ECMA International 2024 115. Breakable statement. Iteration statement 1. Let new iteration set be the list concatenation of iteration set and label set. 2. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G.
I'm gonna ask Jeppa if it changed anything at all
Iterations
between its output and what I gave it.
1
Then I'm gonna figure out whatever the heck is going on.
C
It should work. So it's something after this thing.
I N
Unless Jeppa's wrong, which probably is.
N D
It's just stupid.
F
It's annoying as hell.
capital C O.
This is a terrible puke. I almost... Yeah, puke, I guess. It wasn't a puke, though. It's like a burp. But like a wet burp.
E.
I thought it'd be more dry than that. It didn't taste very good.
Find labels is true. Return true. 3
This is so boring.
capital C O
I just want to make a fucking triangle.
A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. Of statement list item with arguments iteration setend. If statement, if expression statement else statement 1. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration second. If statement, if expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. Do while statement, do statement while expression, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. While statement, while expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. For statement, 4. Expression statement, 4. var variable declaration list. Expression statement, 4. Lexical declaration expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. For in of statement, 4. Left-hand side expression in expression statement, 4. var for binding in expression statement, 4. For declaration in expression statement, 4. Left-hand side expression of assignment expression statement, 4. var for binding of assignment expression statement, 4. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement, for await. For declaration of assignment expression statement, return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration second. Note this section is extended by an XB. 3.5. Continue statement. Continue. 1. Return false. 16. ECMA International 2024. Continue statement. Continue label identifier. 1. If iteration set does not contain the string value of label identifier, return true. 2. Return false with statement. With expression statement, return capital C O N T A I N S, capital U, N, D, E,
The stream's almost at 12 hours, whatever.
D, capital C,
So I'm gonna let it run on for 10 more minutes and
I,
start on a stream.
U, E, capital T, A, R, G, E, of statement with arguments iteration second. Switch statement, switch, expression, case block, return, capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case block with arguments iteration second. Case block, return false, case block, case clause assopt default clause case clause assopt. If the first case clauses is present, then A if capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of the first case clauses with arguments iteration second is true, return true. 2. If capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of default clause with arguments iteration second is true, return true. 3. If the second case clauses is not present, return false. 4. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of the second case clauses with arguments iteration second. Case clauses, case clauses, case clause 1. Let as undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clauses with arguments iteration second. 2. If has undefined labels is true, return true. 3. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clause with arguments iteration second. Dart case clause, case expression, statement list opt. 1. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of statement list with arguments iteration second. 2. Return false, default clause, default, statement list opt. 1. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration set. And 2. Return false labeled statement, label identifier, labeled item. 1. Let label be the string value of label identifier. 2. Let new label set be the list concatenation of label set and label. 3. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of labeled item with arguments iteration set to new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. 1. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N